Just started.
Yeah. Good morning, one and all. A warm welcome to the fifth day of faculty development program. It gives me a great pleasure to greet you all. We continue this enriching academic journey. It's my great privilege and honor to introduce our esteemed resource person, Dr. K. Adalarasu sir, professor in School of Electrical and Electronics Engineering, SASTRA deemed University, Tanjavur. Dr. Adalarasu is a distinguished academician, researcher, and a mentor who has career span of more than 2 decades of excellence in teaching, research, innovation, and professional service. He completed his bachelor degree in electronics and instrumentation engineering and his both MTech and PhD degrees in biomedical engineering from Indian Institute of Technology, Madras. So throughout his professional journey, he has served as several institutions including IIT Madras, Anna University, VIT University, PSNA College of Engineering and Technology, SASTRA deemed University. Sir interested cover a wide spectrum of emerging areas such as biomedical signal processing, cognitive neuroscience, artificial intelligence, machine learning, deep learning, economics, human factor engineering, and healthcare technologies. He has successfully led the contributed the funded projects, supported organizations such as DRDO and DST. Sir addressing a real-world challenges, healthcare and intelligence system. An accomplished researcher, he has authored numerous publications in reputed international journals 73 and International Conference 54. His work has significantly contributed advancement in WEG signal processing, cognitive workload assessment, and stress analysis, medical imaging, human-computer interaction, and AI-driven healthcare applications. Sir has also guided several doctoral scholars and postgraduate researchers. Beyond academics, Sir actively serves as a reviewer, editor, keynote speaker, conference chair, and resource person for various national and international events. I extend warm and heartfelt welcome to Dr. K. Adalarasu sir for thanking for joining today. This session over to you, sir.
Thank you, sir. Thank you for the introduction. First of all, I thanks to organizer for providing for today's session that they can get. You should just inform me then.
Yes, sure. Yes,
okay, sure, actually, today's session we talk about the machine learning for engineering system. Nowadays, it's a crucial role for irrespective of domain specialization. They start from the civil, ending with the biotech field. Now, machine learning is one of the sub division for the ML technique. AI technique. They can make it your system. This is okay. So first of all, we move on to the introduction about what is the intelligence. What is intelligence? Why they can make it? So what is the intelligence? It's the ability to learn, understand, and think in logical way about the things. That is not our human brain. Some people call it intelligent. So they are ability to think, like all the thing, logical way, and then so ability to do this well also. They can. Suppose
sir, sir, your voice is breaking, sir. Sorry for the interruption. Screen is visible, sir. Dear participants, due to network issues, sir, sir, your voice is clear, sir. Yes, sir.
Okay, now video off பண்ணி தான் இருக்குதா அன்மியூட் பண்ணி தான் வீடியோ
சரி
அதுதான் ஆமா ஓகே ஓகே நான் என்னுடைய ஸ்லைட்ல இருந்து போடுறேன் வாய்ஸ் பிரேக் ஆயிடுச்சுன்னா சப்போஸ் நீங்க உங்க பிபிடி அனுப்பிட்டேன் உங்களுக்கு நீங்க அதை யூஸ் எப்படி வேணாலும் நீங்க ஓகே 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 ஓகே
sir, now you can share the screen, sir. Your voice is clear, sir.
Sir, my voice is audible?
Yes, sir. Audible, sir. Screen is visible,
okay.
Sir.
Okay. Okay. Sorry for network issue. Okay.
Yes, sir.
Okay, just already we start about what is the meaning of intelligent, how the intelligent is a play role. That is now how artificial intelligence actually play role. They can make it a system. That is now. So according to the Stanford University scientists, they give the some definition about the AI. So it is a science and engineering for making intelligent mission. They can make it not simply they are not tell the mission is an intelligent mission, especially intelligent computer programs. It's related to the similar task of using computer to understand human intelligence. That is one of the crucial important points they can play a role. So, but AI does not have the confined to the that is. So this is actual definition given to the Stanford. It is in 2004 them for in specific. That is an only narrow mind. They design a mind in a super way. They can design your narrow intelligence. What is the meaning? They can make it your name. So AI trained and focused for performing specific tasks. That is I narrow mind. They want the instruments. Why not the more or anything? Some specific tasks they are not in it, they design a model. They can make it. It's related quality. So, example, to solve the weather prediction, translation, capturing now all the things are each having one thing can do all.
Sir, sir, sorry for interruption. Your voice is again breaking, sir.
That would be and never system play and strong which intelligent and super intelligence nowadays they start working on super intelligent. They not only prediction, they take own decision also. That situation make your system. So types of intelligence system, they to classification on the capabilities based on the functionality. Just now only we discuss about the narrow AI, AI and the super AI. So more super AI system design, they can make it a system. So on the functionality, they make the machines limited memory functionality. How they design the function of the broad domain. Inside they can come to the deep learning. That is nice. Sub instead of sir, my voice is still breaking or
Yes, sir.
is audible or breaking? Still breaking.
Sir, now it's audible, sir. Before 2-3 minutes, some interruption is there, sir.
Okay, okay, okay. That is nice. Okay,
Yeah.
okay.
Yes, sir.
Right, that is okay, okay. That is screen also visible. PPT or
Sir,
one
PPT not visible, sir. Can you share
minute,
once
one
again?
minute, one minute.
Yes, yes, sir.
Now visible.
Yes, sir. Now visible, sir.
Okay, okay, okay. So
Thank you, sir.
next level, okay, next level we make into the machine learning, where third level system they can make it. It's a subset of AI that enable the system to learn from the data and improve the with experience. They can make it. One of the example for machine learning technique, logistic regression, all the things are play role. Finally, their entire combine is a AI, artificial intelligence. It's a broad field of creating intelligent system that can perform task with human. Is a look like a human. They can make it. Example, knowledge based system, all the natural language processing, they are play role for now is AI techniques, they can make it. So what is the difference between the conventional program and machine learning? They can make it. In the classical programming, they can we make the rules, we give the data, they can give the answer. That is in the classical programming. But in machine learning, we make the data, we make the answer. They create the rules. But initial in classical program, we won't create the rules, finally get the answer. But here they are not. Meaning, example, what is the difference between the classical program and machine learning? In classical programming, we can make the threshold. Example, your data can make, crossing the threshold of zero point 0.4. They consider it's an abnormal condition. Your data below the 0.4 level is at normal. But in the machine learning, we are not making any threshold rules. They can only can give the data and normal, abnormal. That answer we can give them. They can make its own rules. That is the difference between the your classical programming and the machine learning system. So what is a machine learning system? Actually, is a machine learning is a field of computer science that gives the computing the ability to automatically learn without being explicitly programming. That is, they can make it. And the learning from the experience. They are learn from the experience on the data to make the prediction also. Example, in the machine learning, so we have some many type of data set. So this data set we can split the training and the testing. So your model can be trained from the data set. So once if training is done, we are given to unseen data. But the training we can give the seen data. Already know the structure of the data. They can make it in the training time. But in the testing time, we can provide unseen data. That is now. So from this already already trained our model, our unseen data can be predicted. This kind of. So this is a common idea of the your machine learning. How the machine learning is a play role. So machine learning algorithm, there is a 4 category actually, depending upon there is a supervised or unsupervised. Whenever you are more to the supervised learning is a classification and regression. Most of the unsupervised learning clustering. That is it. So next slide clearly give the information about the what are the different types of learning technique. So there is generally 4 type of machine learning technique. One is a supervised learning, meaning one person can give the learning ideas, all the things they can make it. through the some person they train the model. That is meaning. So example, what is the meaning of supervised learning? Is a labeled data. Most of the predicted outcomes. Example, email spam detection, house price prediction. All the things are your supervised learning. Unsupervised meaning your data is not labeled. Unlabeled data. We are not labeled. This is example normal. This is example abnormal. That is not a unsupervised learning. That is not. So find pattern. They are using the pattern or clustering concept. They can grouping your system. So customer segmentation, anonymous detection, anything abnormality in the machines, all the things they are using unsupervised learning. So next third category is a semi-supervised learning. Is a labeled and unlabeled data. It consists of both labeled and unlabeled data. They improve the accuracy. Why they want to the nowadays semi-supervised learning? They are improving the accuracy. So example is a image and a speech recognition and a texture classification. Is considered a semi-supervised learning. So last one is a reinforcement learning. RN, we call this a RL, reinforcement learning. Nowadays a crucial play role. So they can make it a reward and penalty. Your system is working good, they give the reward. Where they can predict the wrong way, they can give the penalty. Look like this type of concept. They are using reinforcement learning. That is learn by doing. That is they can make it. Most of the robotic system they are working on reinforcement learning concept only. Next one is a self-driving car. They can some other example for reinforcement learning. So what is a supervised learning? Is algorithm learned from the labeled data. That only told them your data are labeled. They are classified already. Labeled classification is given. So where both input and desired outputs are also known, they can make it. So what are the prediction outcome of the classifier data set? Example, linear regression, logistic regression, decision tree, random forest, supervised vector mission, k nearest neighborhood, and neural network. All the things are under in supervised learning concept. They can play role. For unsupervised learning, I told them as unlabeled data. We are not target. We does not know what is the final target output. That is not. So algorithm learn pattern from unlabeled data without predefined output. That only told them we are not defined any predefined classes. So discover hidden structure and relation. How they can learn it from this? They learn from the hidden structure. They can make it. So some of the example is a k-mean clustering and hierarchical clustering. Density based spatial clustering of application with noisy, they can make it. So next one is your PC, principal components analysis, autoencoder. All the things are under unsupervised learning, meaning we are not providing any labeled data structure. That is not. So using the in-depth learning is a learned pattern. Algorithm learn the pattern. They grouping the cluster. They can finally give the classification. That is for unsupervised learning concept. So this is actually this picture can give them. So I told them it's a third category. It's application with noisy. Example, they are grouping, clustering. So group A, group B, and the noisy. One group is can be considered as a noisy. So how they can then from the understanding the pattern from this, they can finally get it this type of learning concept. So third category is a semi-supervised learning. Use a small amount of labeled data together with a large amount of unlabeled data. Meaning small data set having is labeled, remaining large portion of data is unlabeled. They can make it. So improving learning when labeled data is expensive or difficult to obtain, they are using self-training, co-training, label propagation, semi-supervised SVM. Not general SVM, semi-supervised SVM. So these are the things used for semi-supervised learning concept. So last one, reinforcement learning is a nowadays is a crucial play role for all the things. And agent learn by interacting with their environmental and receiving reward or output. Very carefully, this actually how they can make it. Example, robo. I can design a robo for real application. So in robo, they can see the real environmental situation, present situation. That is, they take the action. So robo can clearly take correct action. They give the reward. The robo can take the wrong action. They can make the penalty. Look like this type of action can make it in reinforcement learning. Example, Q learning, that is a SARAC meaning state action, reward, state action. Next, deep Q network also one of the reinforcement learning, policy gradient and proximal policy optimization. That is name. So example, one of this, observe the state. Your system can observe the state. Selection action, meaning suppose your robo can see some obstacle. That is so observe the obstacle. They take the action. They want avoid obstacle avoidance robo, meaning they take another path. They can so selection action. So executing the action. So observe, reward, or award. That is only. So observe, reward. Agent receive the feedback from the environmental. Update the key value every time. Weight can be updated in the reinforcement learning. Weight can be updated. So this is the fourth category of algorithm they are using in the AI technique or machine learning. That is learning technique. Sir, my voice is audible, correct? My voice is
Yes, sir.
audible?
Audible. Yes, sir. It's
Okay,
audible.
okay, okay,
Yes,
okay.
sir. Yes, sir.
Okay. So next one is machine learning type. That was already previous slide I clearly told them is a supervised, unsupervised, semi-supervised, reinforcement learning. You are supervised learning. We are under two category. One is a continuous target variable. Next one is a categorical target variable. In the unsupervised learning, target variable not available. That only I told them. In the supervised, we know the target. Example, normal, abnormal. But in the unsupervised, we does not know normal, abnormal. That is not. They can make it. That only target variable not available. In the third category, categorical target variable, semi-supervised, reinforcement learning, both the things. Category target variable not available. Both. They are working both. They can make it your system. We move on to the continuous target variable. One of the things, regression. Example, house pricing prediction. In the category target variable classification. So most of the machine learning they are using for classification also prediction also. That is both the thing. Prediction they are using regression type. They can use some. So classification, medical imaging. If you move on to the unsupervised clustering and the association, I told them here not a regression classification, it's a clustering, grouping. So this entire data set come to the normal. This is abnormal. It's a clustering, association. One of the thing, customer segregation is a royalty customer, is a low customer preference, customer preference. They are given. Is a look like a unsupervised learning. So market basket analysis. If we move on to the same semi-supervised learning, one is a classification and a clustering. Here also textile classification, land finding of GPS data. Example, if you are reinforcement learning, they can put on the classification and the control. So most of the control mechanisms they move on to the reinforcement learning, meaning they see the situation, they take the action in the reinforcement learning. That action can be good or bad. How will they decide? Penalty or reward? They given reward is a good, your action is correct. They give the penalty, your action is wrong. They can go to some other state. So that is an example in classification, optimization, marketing, in control mechanism, driverless car. They can make it your system. So in A, this slide actually given A in mechanical side completely. So in manufacturing side, what is the supply chain optimization? Next one is predictive maintenance, your machines, all the machines, predictive maintenance, industrial and collaborative robotics, they can make it your system. Product development also, energy management, all the things A in manufacturing sector is a crucial play role. They can make it. So this slide actually given to the, what is a pipeline any machine learning? From starting to ending, even sensor data, ending, what is a pipeline? So first one is a data collection. Example, weather data, geographical data, energy price, many things, many data variables, they can make it. So next, this data given to the data pre-processing, meaning what are the pre-processing, any missing data is there, all the thing, meaning data cleaning, data organization, data analytical, algorithm creation, model iteration, data visualization, insight, all the thing. So first, your raw data coming from the your system, they we want to do some pre-processing of the data. Once pre-processing given to the model and optimization, given to the model. So training, validation, prediction, and optimization. Next, you make the one of the concept is optimization. Once not finally come to the one model, which model is better and what are the optimum model for we need, that one we can make it. So finally they move on to the evaluation and deployment. Finally your model put it in the hardware system, they can make it your system. Why we are clearly we worry about the optimization? There is an algorithm, we need a computation, that is why. So we don't take the more computation power and your delay also, your computation delay, that is your delay. So whatever your algorithm, it can quickly give the response of the system, that is they can make it yours. So once only data can be ready for your machine learning or AI readiness, what are the key element is a clean normalization of the features, proper labeling, balanced data set, fixed input size, they can make it. For data structure, what are the play roles? Is a rows, is a tiles or epochs, all the data variable. Your column considers your feature matrix, your separated metadata, subject or condition, all the things are play role. So here one of the concept before given your data to the model, we need a normalization, data normalization. What is the meaning of data normalization? I give one simple example. Suppose you are predicting the automobile sector in AI or machine learning. That is in automobile, what are the different parameters will come? What is a tire pressure? Second one is a speed, velocity, your oil, coolant oil, engine oil, all the parameters they can make it. Each example you are want to the speed. Speed is 120 kilometers per hour. If you want the tire pressure only 40 or 20 psi. So your numbers are huge variation. That is now. So this we don't want this are the variation between the parameters, features. So before given to your model, they normalize it between 0 to 1. So entire your features are converted into 0 to 1 normalization. That now you are feeding to your model. So once you are feeding this type of thing, your model, what are the prediction is a good. That is a reason previously where the features are a huge variation of the clustering, huge variation. So only they are doing data normalization and scaling. So ensure the fair contribution of all the features, improving the training stability and the convergence. Third one is preventing features with large magnitude from dominating learning. That one I told them. So one feature is dominant, meaning large values, huge values. Another feature is only within less than 2. Another one is greater than 1,000. This is large magnitude variation. To all the things, avoid using the data normalization technique. So next one is enhance the model performance and the generalization. So what are the data normalization technique used in ML? One is for minimax between the 0 to 1. That is what are the outer layer given the sensitivity is very higher. Typical usage, your CNN, neural network, all the things. So second, your data normalization is a set score using mean and standard deviation is a medium sensitivity. Next one is a robust unbounded low and L2 normal. So these are some of the normalization technique. There is many normalization technique. I put in slide few only. That is. So before give it to your model, your data can be normalized within the range, not huge variation between the features. They can make it your system. So next one is a feature selection and a dimensionality reduction. That is a play role. So what is the need for feature selection and the dimensionality reduction? They can make it. So first one is to avoid overfitting. Second one is improve the generalization. Third one is reduce the combination. Meaning, suppose I give the 100 features for my model for predicting final good or bad. Instead of 100 features, reason 100 features, they computing 100 features, finally your model can give the result. But instead of 100 features, I can decide which are the features are very dominant. That is, which are the features are not relevant to my application. That is, out of 100 features, 20 features is very crucial player for my model prediction. Only select that 20 features. Now, what are the benefit of this one? To avoid the overfitting. Next one is they reduce the delay, computation delay. Instead of 100 features, they are using now only 20 features. And they can save the power of your hardware system also. They are making your system. So what are the technique they are using? The feature selection, statistical tests using the ANOVA and the correlation analysis, PCA, principal components, linear discriminator analysis, regression feature elimination, and mutual information. Some other technique. Nowadays, advanced AI, they are using shape, that is an adaptive shape or extra AI technique. They are using for feature selection. That is now advanced, they are more on to them. So same feature selection, dimension reduction, recurring feature elimination. What is the meaning? Whereas the feature based feature selection method find the most relevant feature by training the model repeatedly and removing the least important feature step by step. Most of the Zig boost model, they are using the tree-like structure. It's a tree. They are making branches that they can make it. Use this concept, feature selection concept. They are using inside. They can make it. So once after feature selection, all the things, you are given your system to your ML model, deep learning model. So how generally your data can be split in 3 ways: training, validation, and testing. That is these are common norms for any machine learning or deep learning, any AI technique they are making. Example: suppose I having 100 questions. One set having 100 questions, another set having only 20 questions. Example: one side having 100 questions, another side having 20 questions. Generally, which one we prefer for training? Is it 20 or 100 for training? Generally, your side answer. Suppose one side is 100 questions, others having 20 questions. For training, I take 20 questions for training or 100 questions for training my students. I want to train my students. Taking 20 or 100. Any answer? Instead of taking 100 questions for train my students or taking only 20 questions, trained my students, training to my students. Any idea which one I can select? 100 or 20 for training of my students for any exams, competitive exam. Suppose I want to train my students in the competitive exam. I take 100 questions for training or only 20 questions I train my students. I can make it other side, 100 is the side. Any guess from the your side? 20 is preferred or 100 is preference for training to my students. Hello? Which one generally if 20 I take only 20 questions I can train my students. I take 100 questions train my students. So most of the I taken 100 questions for train my students is better. Reason we are more training my students performance is good. So only we are making 3 CA assessment before go to the end semester. We are not conducting. We can conduct many tests, weekly tests, all the thing, my thing. So look like same thing. In the machine learning also, we take more data set for training. That is small data set for validation, small data set for testing. So general common procedure, they take 60 to 70% training. Out of 100 data set, 60 to 70% training, remaining 30 in the 30% data that we can make it, they are splitting 15-15. Validation and the testing. So what is the difference between the training, validation and the testing? Training through the label or seen data, through the label, your system can train the model. Model can be trained. But what is the validation? During training, I want to improve the accuracy. So I want to tune some hyperparameters. That is not. So they validate. Still is a label data very carefully. During validation also, they can use a training data set, the small part they are taken. What is the purpose of that validation? You are tuning the parameters, model parameters hyper tune. We get them. So what is the testing? Is completely unseen. Nothing is seen, unseen. For validation, they are seeing inside very carefully. Different between the validation and the testing. Validation, something already seen. But what will happen? Main purpose of validation, they are tuning the hyperparameters. Still is not labeled, and very carefully still is not labeled. But they seen the data structure is seen, but it's not labeled. But the training, their labeled is there. Purpose of validation only hyper-tuning parameters. For testing, they are not seeing any data structure, nothing label is there. That is, they can make it. So generally there is a two type of validation technique in machine learning. One is for k-fold validation, other one is for hold-on validation. So what is the difference between the k-fold validation and hold-on validation? Example, your data set is example, large number of data set, observation or large data set is there. That you can prefer the hold-on validation, meaning example 100 data is there. Example 100 data, I have 100 data. I take 70 data set for completely training. I can hold for 70 data holding, 30 for testing. That is for hold on validation. But what is the k-fold validation? Example 5-fold. Example 5-fold. In the 100 data set, 100 data points, they take first 5 data points. Example 5-fold validation. K is a 5. Example K is a 5-fold cross validation. In the 5 data points, 4 data points used for training, 1 data point testing. So next move on to the 5 to 10. In the 5 to 10, your data for 4 for training, 1 for testing. They are repeating same like that is only we call it a k-fold validation or fold. So example 10-fold, 9 data for training, 1 data for testing. But previous category, entire 70 data hold on for training. So another only for testing. That is the difference between the your validation. That is a 2 type. So why LOSO? That is a one leave one subject out, meaning test real world generation, important for most of the medical field they are using EEG studies. So once our model is trained, how will you get the model performance? Generally in machine learning. So generally in machine learning model performance, there is a many metrics they are using. One is for your confusion matrix, second one is accuracy, third one is a F1 score, fourth one is a precision, recall, sensitivity, specificity, many parameters. That is MCC, Matthew correlation coefficients, ROC. These are the parameters or metrics can quantify your model. Model is good or bad. What are the model you are designed? They are correctly predicted or wrongly predicted. They can make it your system. Correct? That is nice. So your accuracy, what are the finally your model give the accuracy is average accuracy, not class-wise accuracy. They can make it. You want to find out the class-wise accuracy using the confusion matrix. From the confusion matrix. So they are using the precision and recall, and they use the F1 score. That is nice. So this F1 score actually derived from the precision and recall. So some journal articles they are given dominant in F1 score. Some journal articles they are provide precision recall. What way they are different? How some paper, some author they prefer F1 score, some author they prefer precision recall score. Whenever your data is unbalanced, meaning normal condition only 100, abnormal condition only 20. Now data is unbalanced data set. That is nice. So this type of scenario, F1 score given the better prediction or better prediction of the model performance is of precision recall. Your model is balanced, precision recall is a good parameters. So depending upon your data set where you are working, your data is unbalanced, we can select F1 score is a better your model performance matrix. They can make it. Next one is a area under curve, AAC and Matthew confusion matrix. So this is a confusion matrix. Your diagonal element given give the true positive, true negative. That is a true positive diagonal element. And that is other one is a wrong way. Example is actual classes is a predicted classes. So positive they can predict your model can predict the positive, but positive they predict the negative. That is called as a type 2 error. That is meaning is a positive, but your model give the meaning normal, but they given abnormal. Your model can tell them it's abnormal. That is called as a type 2 error. So second category is a negative, they predict the positive, meaning that person is a disease. They predict the normal. In first case normal, they tell them it's a disease person. But second case, your person is a disease, but your model give them is a normal. That is called as a type 1 error. They can make it reverse. So this is next graph is one of the ROC. This is one of the crucial play role for performance matrix of the any ML model. They can make it. So how will you identify your ROC from the ROC graph? Your model prediction is good or bad. Generally, our ROC values from 0 to 1. That is not. So between the 0 to 0.5 is a poor discrimination. Your model can give the worst discrimination. Between the 0.5 to 0.7 is a good. Next one is 0.7 to 0.9 is better. 0.9 to 1 is an excellent discrimination between the true and both the classes. They can make it. So is give them. So below the 0.5, less than 0.5 is the worst. Your model prediction is worse. When you move on to the above level, top level is above left side. Your model prediction is better. They can make it your system. So is an example. Suppose a machine fault detection model procedure. Suppose I use some ML model for predicting the machine fault, some other in manufacturing sector. Example, logistic regression give the 0.82, random forest give the AUC 0.91, ZigBoost given 0.95. Which one you feel is a outstanding discrimination between the fault detection? Out of three model, final justification or final conclusion, which one you can make it? This model can give the outstanding discrimination from this result. Any answers or anything? Out of three model, which one finally we can make it? Which one can give the outstanding discrimination between this by machine fault detection? Logistic regression or random forest or ZigBoost? Sir, my slide is visible, right?
Yes, sir. Visible, sir. Visible, sir.
Okay. Sir. Okay. Which one if generally? I got the AC, ROC. I told you this is one of the parameters for my model accuracy or model performance. Suppose I got the 0.95, 0.1. Logistic regression given 0.82 only. My mission fault detection. That is my next random forest. So I already previous slide I clearly told them whenever you are move on to the one towards the one, your model excellent discrimination between the fault detection. That is only. So another parameters is AVC ROC meaning area under the curve. That is a regional. That is a. So give the another parameters for model performance. So depending upon the year, you can use the precision, recall, F1 score, anything for make it. But confusion matrix clearly given them, and very very important. What are they are running the Python code? They are given final accuracy is average accuracy, not class wise accuracy. That also. That is it. You want class wise accuracy. Suppose class A, what is accuracy? Class B, what is accuracy? Example, in the class A accuracy, how much? Class B. From we can get from the confusion matrix only. They can make it. So if you move on to the regression side, previously in classification, what are the performance metrics they are using? F1 score, position, recall. Suppose you are using that model for regression. There is no. So one of the things they are using the mean absolute error, mean square error, root mean square error, R square. These are the performance metrics. Here we don't consider the F1 score. Very carefully for regression analysis, for model performance, we don't consider the F1 score all the thing. Here we consider for mean square error. They can make it. Suppose what is the meaning of regression and your classification? Example, I want find out my machine is good condition or example, machine is good or bad, mean fault. Machine is working good or fault condition. Take second scenario. This machine presently running. What is the lifetime for machine? Example, another 2 years or 3 years. Now you decide where you want classifier, where you want prediction model. Prediction, we call it a prediction model. That is it. I given two scenario. First scenario, I want machine is good or bad. Second scenario, presently the machine is running. I want how much lifetime for this machine. That is it. In the first scenario, I can use a classifier algorithm. Same machine learning I can use a classifier. There I consider performance matrix F1 score, position, recall. In the second category, meaning my machine working another 5 years. They can at least they can good working condition for 5 years, 10 years. They look like a prediction. Whenever I want to the prediction side, regression is a play role. They can be logistic regression and many regression. There, what is the performance matrix for your model? Yeah, mean square error, that is absolute error. All the things are play role. I think now you understand what is the classifier, what is a regression or prediction. They can make it to your system. So now still I can give some other idea of the what is the machine learning and the deep learning. That is nice. First thing, deep learning, they are learning very deep. They go to many level. That is a common name for deep learning. In machine learning is a surface level learning. They are not more to the deep level. That is nice. Another very important logic way or technical way. What is the difference between the machine learning and the deep learning? In machine learning, you must give the features manually. That is very important thing. In machine, whenever you are planning to use the machine learning, we can give the features manually. Example, speed, vibration, temperature, all the things, features given to your model. But in the deep learning, very, very important, in deep learning, we don't give the features. We given raw data. Example, I take the 1 hour my motor movement, motor parameters. Example, speed of the motor, vibration of the motor, motor temperature, motor current, motor voltage. For suppose this, I want to design a ML model, I can extract the features from the example, speed, mean, standard deviation, variance. I manually extract given to my model. But in the deep learning, I don't want any extractor feature. What are the raw signal coming to your vibration signal? I directly feed it to my model. So your deep learning model, they take auto feature extraction and they use the classification. That is only. So different. That is the difference between machine learning and deep learning. Learning wise also different and your procedure wise also different. Feature extraction mandatory for classification, machine learning. But deep learning, they take automatic feature extraction. So example in machine learning, ML in engineering side, digital twin, predictive maintenance, smart manufacturing, predictive maintenance. When my plant can be maintenance next 2 months or 3 months, not manual. All the things are automation. Our AI technique can give them this suggestion. So tool wearing prediction, fault diagnosing, predictive maintenance, and structural health monitoring. These are the things they are using in an engineering side. So what is the meaning different between the traditional and the deep planning? So traditional ML, already I told them we need a features manually and feeder. Example, where SVM, KNN, K nearest neighborhood, random forest, linear discriminator analysis, record and graph feature. That all I told them is we need a features. That is not. But in deep planning, example, your CNN, convolutional neural network, LSTM, transfer learning, all the things, transformer learning, we don't want feature extraction. Inside model having feature extraction, they can make it your system. So actually this slide can give them deep learning and machine learning. If you want the machine learning, supervisor, unsupervisor, very carefully, that is a classification, regression, that is they are using clustering. If you want the AI, artificial deep learning technique, they are using CNN, convolutional neural network, that is a recurrent neural network, GAN and perceptron, MLP, all the things are they want the deep learning technique, they can make it. Our CNN also they can consider as a deep learning. So this is a traditional deep learning. One of the things are typical. You are making your CNN, they can make it your system. Typical CNN convolutional neural network still is a neural network. What is the difference between the MLP, multi-layer perceptron, and convolutional neural network? That is a structure-wise, there is an architecture-wise different. There is a many layers, input layers, hidden layers. That is an example is input images. They are using convolutional layer. There is a max pooling layer. One more convolutional layer, max pooling layer. Finally come to flatten layer. So finally come to normal neural network. So this blue color given to normal neural network. But the remaining all the things are your conventional neural network. That is they can make it. So this is a feature map. I told them very carefully what is the difference between the your machine learning and the deep learning. Machine learning, we manually extract the feature, feed it to our system. But in deep learning, we don't want manual feature extraction. Our model can extract what are the feature they extracting. They can make it to our system. So this all the conventional pooling, conventional, all the things are used for feature extraction. That purpose only. One feature extraction come to normal our neural network. That is finally go to the your classification dog or anything. So this is called as a fully connected layer. So feature extraction, classification, probability distribution. They can make it your system. This is a typical conventional neural network. So whenever you design your own architecture, CNN architecture, how many conventional layer you need, you fix it. How many max pooling layer we need, all the things are you design your own architecture. That's possible, depending upon your application. Finally, what is the target? What is the input? What is the target? How many neurons need in output side? Only two classification. 2 neuron is sufficient output classification. They can make it your system. So this can, next one is a recurrent neural network, RNN. Nowadays RNN is a crucial play role. They can make it, and the LSTM both are same. Recurrent neural network and LSTMs are both are same. But what is the difference between the your conventional neural network and RNN? That is in conventional neural network. Most of the time series, that is meaning sequence learning. That is not. They are not considering features. That also past also, and very important. There is no feedback mechanism in CNN. We don't have any feedback mechanism. They are not consider your past. That is not only feature. They can make it. So in the RNN or LSTM, they can consider it a past also. So depending upon the past, they are updating the weight. That is one of the difference between the CNN and RNN. CNN we don't want in the past thing, but in RNN we need a past parameters, all the things. So RNN or neural network that can process sequential data such as the text, audio, or time series data. Most of them. Whenever I use the time series is a past, present feature. In time series data having past also. That is we can make it. So they containing hidden state that passing from the one element in the sequence of the next, allowing the network to remember information from the previous element. At each time step, RNN take in an input and the current hidden state and produce output at any hidden state. Very carefully each step. They can compare the past value also. That is what present state I want to take, update the weight. Every time they are updating weight. That is a crucial play role RNN. That is a LSTM. That is a long short-term memory. So I use the memory. I need some past events also stored in the memory. So there is a memory in LSTM, but CNN does not no need for any memory. They are not considering any past events. They are taking current and future only. That can make it. So only LSTM having RNN having memory. So long short-term memory, they can make it a system. The output new hidden state are used to input of the next time step. This process continues until the entire sequence has been processed. RN are well suited for tasks involving variable length sequential and maintaining stage across the element. So advanced RNN variety, what are things? Long short-term memory and groove. Get a recurrent unit. Recurring, all the things are your RN. That is that LSTM only by LSTM, nothing by direction. What is the difference between LSTM and by LSTM? LSTM only one direction, is a forward or backward. But by LSTM both, forward and backward also, meaning present, past, future also. But in LSTM they consider only past. In by LSTM they consider both, all the three, present, past and future also. That only by direction. We can use the by LSTM. So this is RNN, LSTM, GRU and transfer learning. Nowadays they are using transfer learning model. So what is the meaning of example for this slide can give the application of RNN, machine translation. Google use LSTM for Google translation. That is machine translation. They are given language translation. Now they are using LSTM concept. That is question answering app used for LSTM in see Amazon, used for LSTM for Alexa. What is the meaning? I can give a better example for RNN. In the making your Amazon, every day you are touching some material or some other items. After 1 month they give the feedback, this material price is low, you won't buy it, meaning they train your model. They train your Amazon inside background, they train your model. This person every day they are whatever, so they take what are the features, cost, what are the fast you are liking the items, they can give the suggestion now present. That is only they are using Amazon, they are using LSTM concept. Various natural language processing tasks, part of the speech tagging, name entity recognition, statement analysis, all the thing. Speech recognition, Android speech recognition based on the LSTM, RNN concept. So LSTM, RN both are same, not new things. LLM can play role, LSTM. So some of the transfer learning concept also they play a role. What is the meaning of transfer learning? Already it's a predefined model. Very, very important. That is what is the meaning of transfer learning model? They told them it's a transfer learning model in deep learning or RNN. So already model is pre-trained model. Their architecture is same. They are pre-trained for some of the 1,000 or 1 lakh images. Example, they train the cat, rat, image identification, animal identification. They are using 5 input image. They take the 1 lakh image trained. They finally get the one pre-trained model. Suppose you are planning to use this pre-trained model, we call it a transfer learning. We call it that model is a pre-trained model or transfer learning. Already model architecture is defined, predefined. You can take that model for your application. Only one small changes, flatten layer, final layer we can change. That pre-trained model, they are designed for five classes, but you are taking your model for your 2 classes. So only final end we can change that small changes in the pre-trained model. Remaining architecture, your flatten number of flatten layer, your remaining things are same. Only end small change you can do for your application. So only they are called as a transfer learning. One of the things VGG 16, VGG 19 is a pre-trained architecture, in-depth architecture. So simple, deep CNN, good for small, medium data set, high parameters count. Some other resonant model also 18, 34, 50, 101, 152, many model. So residual skip connections, excellent gradient flow, widely used for medical and biomedical imaging. They are using resonance model. So resonant 121, 116, deep learning 201, that layers. Whenever we can go to the 2-1 level models, they take computation time. Only one drawback is they are deeply learned. One side is accepted, they are learning very deep. 201, there is a 201 conventional layer, flatten, many things are there. That is one thing, they take more time for computation. So density feature racing, that only I told the density feature reuse, fewer parameters than resonant, good for texture based task, example SEM and MRI images. Next one is inception model. Nowadays they are V3, V4, now V7 come. Inception model, most of the object recognition, they are using object recognition that can make it. That is some of the automobile sector, they design nowadays your driverless car, they are using inception model, V7 or V6. Multi-scale conventional path, efficient feature extraction, automatically. That only I told this transfer learning, type of transfer learning, domain adaptation, cross-linked learning, multitask learning, sequential transfer learning. These are the given to transfer learning model. So what are the transfer learning model? Vision transform. Another one is vision transform, twin transform, data efficient image transformation. Next, another one they can use a natural language processing or LLM. Both are same. Natural large language modeling and natural language processing transfer model. They are using BERT and Albert and RAG. RAG. All the things are some of the LLM model. They are using the concept. All the machine language modeling. So next in the ML or deep learning, irrespective you are ML deep learning, suppose you are having small data set. Example only 100 data set. You are using only 100 data set, you are train the model, you are make one better model is not a good suggestion or good selection. That is not. So how I can way improve my data set? I have only 100 data set. My experiment is over. I could not possibly make one more time all the thing. That is not. So how will I can increase my data set? Old and previous before Gen AI, initially how they are increasing the data set or they call this augmentation. This technique is called as augmentation. How previously they are making, they take the data, example image, you having only 100 image. I want make the 1000 image. So how they make augmenting data? Initially they are using the flipping, flapping, rotation. These are the concept. Another word smooth. Under sample, over sample. They are using SMOT. We call it SMOT. That is not. They are using previously. These are the things for data augmentation. Olden days they concern. Now they want to generate AI. We call it a GAN. Nowadays they are using the GAN concept. What is the difference between the your previous data augmentation using generative AI technique? In previous augmentation technique, we are not using any model, CNN model. We are not using any model architecture. Only flipping, rotation, that is all the thing. But now using generative AI, GAN technique, we use some models, architectures. We can generate the synthesis data. That is not. So this is a data, generative AI is a data augmentation, synthesis, data generation, engineering design, most of the crucial types of the GANs. That is not GAN, that is not conditional tabular GAN, doubly GAN, diffusion model, many things they are making your system. So one is a generative adaptive adversarial network that only called as a GAN. So goal of GAN is a generating synthesis data that nearly indistinguishable from the real data. Very carefully, indistinguishable. So what is a GAN? In mathematical, what is a GAN meaning? So it consists of two neural network. Very carefully, previously you are flipping, flapping, rotation. There is no neural network. Simply you are rotate 20 degree. We get one image 30 degree, another image 40 degree. But here in the GAN, you can use a neural network. That is nice. There is a two neuron. One is for generator, other one is a discriminator. That completely against each other game theoretical framework. Here they are using game theoretical framework. Generator create a synthesis sample. Discriminator distinguish between the real and the fake sample. Meaning there is a real image. You are augmenting one image. This image is look like exactly image or worst image. That only this discriminator can do. So generator generate the new image. What is the discriminator can check it? What are the generated image look like exactly real image? The reason you are data augmentation or is a fake. It's a worst image. Is a making. That is they can make it. That is so most of the chat GPT whenever you given to your facial image, face image, they generate look like a good image. That is they are using this concept. Generate AI. They can make it your system, discriminator and generator only. So in GAN architecture, generator, they are having noise, they can make it, generating data, real data, discriminator, they can give the fake data or real data, they can make it. So there is a deep conditional GAN, there is a many type of GAN is there. GAN, they are using some architecture. So conditional GAN, generate the data condition on tables, cycle GAN, image to image translation, example, horse to zebra conversion, stylist GAN, generate high realistic human face. Now only they are using stylist GAN. That is so all the things that is generative, that is they can generate the augmenting data. You want only less number of data. Reason if you want the high level deep learning architecture, we need a large data set, 1000 data set or 10,000 data set. You are currently only a 500 data set. I want 10,000 data set. They are using this concept. Nowadays there is a generative AI. It's a GAN technique. They can make it your system. So it's the next finally is a time GAN generate for time series and a sequential data. So depending upon your application, you select which type of GAN we need. Suppose you are using tabular data, you can use a conditional tabular data. You are using image data, you can take some of the stylist GAN or some of the cyclic GAN. They can make it your system. Suppose you are using time series data, mission. My mission vibration is a time series data. You want augmenting data, you can take the time gap. That is depending upon them. This is a generative. So another in machine learning technique, there is a external artificial intelligence, XCA, meaning your machine learning is a black box model. What are the features? Example, you are given 20 features. From the 20 feature, your model can give them 2 classes. He does not know inside what are the going on. Most of this XAA crucial play role for medical side. Doctor cannot accept. When now doctor can accept, sir, I designed my AI model for cancer prediction. They are not accept. Reason they want trust of your model, transparency of your model. So they use nowadays they are using XAA technique for transparency of your model. So this is the capacity to comprehend and articulating the rationale behind the AI decision, emphasizing the importance of AI bring not only transparent, very careful, not only transparent of our model, but also understand the user and the stakeholders. Your model, stakeholders can understand your model. So only the XAAs play role, not simply. So generally your deep learning AI models are simply a black box model. Inside what is going on, we does not know. Suppose is these 20 features. Which are the features can use for class A? Which are the features can use for class B? They are not properly given. Get this one. So now XAA technique can crucial play role. So what is the XAA can help the answer? What are the answer they can make it? Why did the model make this prediction? Why this model can why prediction for class A? Why class B? They can give the information. Which features influence the decision most? Suppose normal. This normal, which are the features crucial play role? My mission is good condition. Which feature is a vibration or temperature or current or voltage? They given this decision about them. Excel. Can the prediction can be trusted? What are I can predict them is a good trust worth. How confident is model? My confident my model is the model is fair or unbiased. That is so all the things we can get the information from the XAA, XAA. So 4 pillars of XAA. One is the explanation, accuracy, meaning, and the limiting. That is only nowadays XAA. That is it. So evidence are the for all the output correctly reflect the process that generate the output, understandable and intended user operate only under condition for which it was designed or when sufficient confident on the output. This is the 4 pillar of, so very carefully this example concept play role, your model transparency. Generally our ML and deep learnings are black box model. I want transparent of my model. What are inside going on? How features are play role for model classification? They example can given. So feature trend generally now they are more to the XAA, TinyML, HA, Generate AI, Federal Learning, Output Learning, Quantum, now Quantum machine learning is a meaning speed, computation speed. There's none. So what are the results of generally there is smart manufacturing, autonomous vehicle, sustained engineering, human generated AI, all the things. So what is the difference between the federal learning and general AI learning? What are the model design? Depending upon the only particular data set. Your model can be designed finally for the what are the model for only 20 data set applicable. What is a federal learning? What are the I design my model? This model is suitable for CNN mission, that is your late mission, anything. Willing mission, example, all the 5 missions or 10 missions my model can work on. That is called as a federal learning. That is not. While general generative or general your AI or model you generated, my model work on only late. My model working on only CNC mission. They are not working. But what is the federal is a common model. They can work on 20 or 30 missions also. They are working. That is the meaning of federal learning. So I told the XAA is a postdoc and a transparency of the model. Generally in model agentic, they are using limb shape, kernel shape, that all the thing, most of them, if are model specific, meaning your image, you are dealing with their image. GradCam image, GradCam plus all the thing. So they are given is a model transparency. These features are given model transparency. For transparency, tree-based model, line model, decision tree, all the things. So transparently interpretable and trustworthy of the human, especially in critical deep learning, one of the things shape is example. Shape features can give the transparency of our model. Limb, local interpretable, model agistic explanation. What is a shape? It's a global explanation. They given global level features important. They are given local level. Limb can give the local level. GradCam and GradCam plus plus produce a heat maps. They are given image actually. GradCam and GradCam give the image. These two are given to the feature matrix. I give some example. How will you look like? So this is example A for feature important. Example, these are the features. I can show them. So I have two classes. One is forward and backward. I want classifying two activity. One is forward activity, backward activity. From the EEG signal, all the things. So I extract around 20 features. I given to my machine learning model. So they can give them this NA. Example is a NA feature. Is a crucial play role for both forward and backward. So is example, this BGR feature is not an important feature for significant or making discrimination of these classes. So this only clearly give the feature importance or transparent of your model. They can give them using X-ray. So it's a shape is one of the features they are generally used. So I already told them it's a transparency, interpretability, accountability, X-enabled. They can give your system. So enhance the trust of the user and stakeholder. Make the decision X-enabled. Meaning, sir, you told them, sir, I designed one model for manufacturing sector. Your company people, how you want to accept this one? You having transparency of your model, sir. I designed my model. My model clearly told them in the vehicle parameters, this parameters crucially play a role for predicting my mission is good or bad. That is not. I having my model is a transparency. All the information you are given, they are ready to accept your model. So there, that wording is a XA. That technical wording they are using XA. They are given fairness, competence, and ethical responsibility also. Support legal regularity and ethical requirement for fairness, accountability, and transparency. These are example A for engineering system, predictive maintenance, predictive mission failures, explanation, meaning, I only told them XA, what is the meaning? Vibration contribute 40%, my mission fault, failure. Temperature contribute 35%, load contribution 25%. Sir, load cannot making contribution or failure of my system. Only my vibration can make it. They can given this type of information, what are your model can design, industrial people can accept. So how we get this information from the X-enable A only, they can make it. So engineering understand the reason behind the failure prediction. From this, they understand which one is a failure, due to which parameter is a failure. So machine learning from black box into the transparent decision support system, enabling engineers, researchers, and practitioners are understanding, trust, and effective deploying AI solution real world engineering applications, they can make it. So already I told them difference between the traditional ML system and machine learning. We need an graph feature trainable system. For we need is a ML. ML we need a feature, and graph feature, manual extraction feature. Why DL is useful? Deep learning provide a very flexible, universal learning framework for representing where visual and linguistic information can learn both supervised and unsupervised. Very carefully, whenever you move on to the DL, they are using both supervised and unsupervised. Effective end-to-end joint system utilize large amount of training data. In 2020, DL start outperforming other than ML technique. Nowadays, okay, not 2010. Now present, they are more to all the things are deep learning concept. They are making first in speech and vision and the NLP, natural language processing. So this is apps, deep learning everywhere. They are using from the internet of cloud, medicine and the biological, media and the entertainment. They can make it security and the defense. They are using autonomous car mission. So nowadays, autonomous car, Google Assist, Alexa, they are using deep learning, not machine learning, deep learning concept. They are missing. So this is a last topic. My one case study I done using this. So what is the actual case study? I occurring the EMG signal from the muscle, I can find out the leg movement. That is not. So leg movement pattern during load carrying scenario, meaning that person carrying 5 kg weight, they carrying 10 kg weight from the muscle signal. Why use this concept? In future, this concept can implement in exoskeleton assistive system, robotic assistive system. I can use for this concept in future. Extension of this work, they can make it. So what is the actually I can use a exoskeleton is a wearable robot system, support and enhance the movement, strength and the posture of the human body by working synchronized with the natural motion. Meaning it's a not a robot. It's a externally we can in real human I can wear the assistive supporting system. That only we call it exoskeleton. It's not a real robot. Assist system for carrying most of this type very crucial for in defense. Exoskeleton wearable exoskeleton mainly crucial play role in the defense. Like soldiers can wear the large load, high amount of weight in load So they want continuous walking. So whenever they tired, your exoskeletal system can take over mechanism. That only they can make it. So here, what is I told them? This is a black box model. That is a high dimensional reduction. All the thing I can summarize how they can make it your system. So what we can done? We can recording the leg muscle. That is most of them knee muscle. Is a triceps and the calf muscles. They are recording. When they take the back load for different weight. Example 5 kg, 10 kg weight they are carrying. We record the EMG signal. They can make it your system from the EMG signal. We are extracting some of the features. ML is not deep learning concept. Here we are using machine learning. So we are extracting some of the features. Example RMS, NS, mean, absolute. These are the features. We can extract the nonlinear feature also. So we can given the feature selection. Initially I told them we don't want 100 features. We design taking few features only. One feature selection, we can make it splitting our data, training, testing, validation. Next they move on the classifier model. Here I use the N assemble, SVM and Naven bias. Finally, the given classification is a 1 kg weighted or 5 kg. This activity is for 1 kg walking. This activity for 5 kg walking. And they can give the XML also. Feature important. They are given transparency of model. This is the EMG system we are using to occurring the muscle signal. That is, we can make it your system. So these are the graph. Finally, your feature selection. These are the feature selection using ANOVA. I can use the ANOVA technique. These are the shape value for given feature importance, which features is a crucial play role for corresponding model prediction. These are the confusion matrix. Out of 7 kg load, out of 7, 4 correctly predict, 3 wrongly predict. For no load condition, 5 correctly predict, 2 wrongly predict. From the confusion matrix, if we can get them, I can take the both left side and the right side muscles. That is not. This is accuracy without feature selection, accuracy with the feature selection. Out of 100 features, only 40 features I select, I give it to my model. My model accuracy can improve. They can give them. So these are the confusion. Whenever I told them any machine learning model, I will give the performance of the model using the confusion, ROC, all the things they can play role. Okay, this is all the things can play role. So this is actually this system we can get it from the some through some fund. So only acknowledge that is we can make it. So what is the your take home from this entire message? They can make it. But machine learning, machine learning is not replacing. Very carefully, I already told them this overall. Okay. So machine learning is a replacing human. They can work, make the smart. That is the purpose. Machine learning or AI or deep learning, nothing. All the things are making work as a smart. That is, they can make it your system. One of the best example, ChatGPT. They can make it very smart. We can finish the things. They can give all the information. It's sitting itself. They can make it. They are not replacing human job. That is one of the very important thing. So next one is what way your machine learning and the deep learning different. In machine learning, we manually extract the feature given to the model. Deep learning, we don't want manual extraction, automatic feature extraction. Whenever your model want a transparency of your model, all the thing, they are using XWA. And another, any machine learning, deep learning, anything. Machine learning also, deep learning also, your data set is very small. Example, your data set is very small. I want large data set. They are using nowadays GAN technique. There is a many type of GAN. That is, they can starting the time GAN to tabular GAN. That is a cyclic GAN. Many GANs are there. You are generating the synthesis data. Previously, they are not using any model. They are using simply flipping, plopping, all the things. Now they are using this concept. And one more, your machine learning or deep learning ending with the language processing, natural language processing or LLM, large language modeling. What is the meaning of large language modeling? I give one example in manufacturing sector itself. My model can predict them. My mission, example, okay, my mission is after 3 months, my mission can be failure. They are getting my answer, my model give them. So what is this LLM can give them? Why this failure? What are the precaution I want taken? Very carefully. That is nice. They give the suggestion also. My LLM model, they give the suggestion. Okay, reduce the current or make the some vibration observation material above your machines. They give the suggestion. So the suggestion can made it from the LLM model, large language modeling. They can make it. How they can give this type of suggestion? Already their scientists they predict them. This mission is failure. Why they are failure? These are the reason only they are failure. So they can go and checking that website. Whenever you get some result. So what are the LLM model? That also model. LLM is a model. So what are the model? Example is a Google. Google having its own model is a RAG model. Another one is a RAG model. That is retrieval searching algorithm. They go to the website database. They are checking this scenario, why this happened. They bring that information given to you. That only large language model can play role. Now entire thing consider a smart. That only smart. We talk about machine learning, deep learning, ending with the LLM, entire thing bring one common, your entire work consider a very smart things. Your manufacturing or digital twin, any place they can make it your system. Okay, so I stop my session. I don't know how much you are taking information. That is nice. Any questions you can ask them.
Dear participants, if you have any queries, kindly ask them, please. Sir, there is a chat box. We have questions, sir.
Okay, I think. What is the questions? Can I read? I will.
Yes, sir. In DC motor machine, for predicting maintenance with enabled data, which model is good or PW form better?
No. In that case, first of all, it, in DC machine, you are predicting maintenance, correct? First of all, you check which are the parameters you are considering in the DC machines. You are taking vibration, temperature, that is a one type of scenario. Example, you have 5 set of features. Example, for that machine, corresponding DC machines. You take 5 set of features. Next, suppose next thing, check your data, how much data set you are available. Example, only 100 data set. You are putting the model, machine learning model. We can take 5 model you are trained. Example, there is a Zigbee, SVM, random forest, each having own mathematical expression. You take at least 10 models. We can predict them. This is one way. Second way, suppose you got accuracy of only 70%. Example, all the 10 models you got achieve only 70% accuracy only. So we cannot possible to stop your model. I want fine tune my model. So that case we can move on to the GAN. Density data can be more data can be generated. That case one of the very important things for GAN, only example 100 data. Example you having 100 data. You can separate 20 data for testing. Remaining 70 data only make the augmentation. Don't making entire 100 data, don't do the augmentation. It's a very important key point here. So example you are 100 data, you want augmenting 100 data. So don't take all the 100 data. Keep 20 data for testing. Don't augmenting that 20 data. It's unseen data. Very carefully separated. Remaining 70 data only given to augmentation. The 70 data can be augmented for 1000. Now you are given to model for training. Once train them, this 20 data set given to your model, now check the accuracy is improved. That is one way for increasing the accuracy. And the second way, we can tuning the parameters, model parameters. We can improve the accuracy. I think I answered.
Sir, another question is there, sir, from chat box.
Yeah.
For the very limited data set of 40 samples, which algorithm is the best one for predicting with high accuracy?
No, that case, you are planning to make industrial oriented, the 40 data set not sufficient. So only nowadays they are MLDL, they are making generative AI, GAN. They make it. Now they are making some mathematical model. You can augmenting your data. If you are using augmenting data, is good for your model prediction. Instead of simply only 40 students, I can validate my things. Instead of 40 students, I want get the feedback. 100 students, the feedback is better. Generally, I got only 40 students, get the feedback is good. Or 100 students using getting the feedback is better. 100 students feedback is better. So that type of scenario. So you are limited as I said, go on to the augmenting your data. There is many augmentation technique. Use the augmentation now train your prediction model. That is a good. I think I answered that question probably.
Sir, actually, sir, Bala Narasimha sir is mentioned that it's for research purpose.
Yeah, research purpose, better augmentation. Go on to the augmentation. GAN.
Yes.
Use the GAN. 40 is not good.
Dear participants, if you have any other question.
The same things nowadays. Your research work can be publishable. All the things, not simply deep learning. Don't stop machine learning, deep learning. You can use a GAN and generate a meaning GAN and LLM also. You can use this type of technique. Their published acceptable rate of publication is somewhat high level. Simply, I use deep learning. I got this result is not a. Nowadays, they are taking much of information in the AI tech, AI side. They can use a LLM also, language modeling. We can implement your work. They are easily accepted it. They can make it. So, any other things?
No. Sir, any other questions, dear participants?
My specialization, I will tell them. Also, the neuroscience, working on biomechanics, human comfort, human ergonomics, all the things. Assistive robo also, small part working. BC, brain computer interface. That is.
Sir, I think no more questions from
Okay,
chat box
okay,
from participants. Shall we go for
okay,
formal vote of thanks?
okay, okay.
Thank you, sir. Sir, thank you for lecture given in the topic of machine learning for engineering system. Thank you for joining this wonderful session, sir. Thank you, sir.
Thank you, sir. Thank you, thank you. I can leave, correct? Okay,
Yes.
okay.
Dear participants, kindly stay with the connections. So within short duration of time, we will start another session. So 12 p.m. Thank you. Thank you, sir. Thank you so much. Easwaran sir.
Yeah, hi.
Yeah.
Hi.
Shall I start with the formal welcome address? Then you can.
Yeah, okay, sure.
Yes. Okay, sir. Shall I start? Okay, sir. So once again, good afternoon. So it is a privilege to introduce a distinguished resource person, S.Jayakumar, Senior Embedded Software Engineer in Research and Development Division of Tata Consultancy Service, Chennai. Mr. Easwaran completed his engineering degree in electronics and communication engineering and has established himself as a skilled professional in the field of embedded system and automotive software engineering. With more than 7 years of industry experience, he has contributed extensively to product engineer design and development, particularly in the commercial of off-highway vehicle sectors. Currently, he is involved in the design and development of advanced automotive braking application software of European and American markets. His role requires deep technical expertise, precision, and innovation ensure the safety, reliability, and performance of modern automotive system. His technical expertise span of embedded system, automotive electronics, model-based design engineering, Python automation, deep learning, and data science. So by combining the traditional engineering principles with emerging digital technologies, he has successfully addressed complex industrial challenges and derived innovative engineering solutions. A part of his professional responsibilities, Mr. Easwaran is an active participant in a technical conference, seminar, and the Society of Automotive Engineers events. He consistently engages a knowledge of sharing activity and professional development programs, reflecting his commitment and continuous learning and technological achievement. So, with this short note, I extend a warm welcome, Mr. Easwaran sir, for thanking for joining and sharing his expertise with us today. So, this session over to you, sir.
Yeah, okay. Thank you. Thank you for your
Thank
words. Okay, okay. So, okay, today I'm going to explain deep learning and computer vision. First, I will give short difference between what is machine learning and deep learning. So, what is machine learning? Previously, Adalarasu sir explained everything. So, even though I'm going to explain, so machine learning is a subset of AI that learns to patterns from the data using algorithms. It's a minimal things. And what is a deep learning? It's deep learning is a completely subset of machine learning part. Then it is comes under artificial neural networks with many layers. It has many layers. I mean, for example, input layers and hidden layers and output layers. So what are the data needs for machine learning? So minimum number of data sets for machine learning. For deep learning we can use maximum amount of data sets, because deep learning has automotive neural networks inside. So in machine learning feature extraction we can do separately. For example, SVM algorithm and then descent tree algorithm, we can use separate algorithms for feature extraction. For deep learning has inbuilt feature extraction layers. So I will go to the next slide. So this is the introduction of deep learning. So already I have explained it's a part of machine learning, and then we need a large number of data set for accuracy, and then it has automatic feature extraction from the raw data whatever we have provided in the raw data. Then it will automatically extract. It has some complex architecture like CNN and RNN. So CNN means convolutional neural network, and then RN means recurrent neural networks. CNN for mostly we have used speech recognition, image recognition, video recognition, and then recurrent neural network we can use for a data science based on projects. We can use it. Teams, any doubts we can interrupt. You can interrupt me in the between. Then I will answer it. I am ready to answer it. It's not an issue for me. Have you understand what is the deep learning I have explained? Karthikeyan sir, please.
It's audible, sir. Your voice is audible, sir. Please
Yeah, yeah.
continue.
Whatever I have explained, can you able to understand?
Yes.
Yeah, teams, please acknowledge it. I have given an introduction about deep planning that I understand you people. Okay, I will go with computer vision. So computer vision is nothing but it's a field of artificial intelligence. What way it that focuses on enable computers to see and interpret the visual information from the world. Whatever we have to do like that. Then brain and eyes. Through the eyes and brain, what we have to do. See like that. We can see some things. For example, helmet is there. Then we can see that easily we can identify it. So same thing we can do that. We can able to do in computer vision. That is the deep learning and computer vision. That is the computer vision. Then deep learning importance. So already I have explained deep learning basics. This is the layers. So input layer means whatever we have inputs, these are the input layers. So hidden layers, we have many layers. One is max pooling layer, another one is fully connected layer. Max pooling layer is nothing but so we have 4 cross 4 matrix. So in pooling layer, one is max pooling layer, another one is average pooling layer. Max pooling layer means then 4 cross 4 matrix. It will divide into 2 cross 2 cross 2 cross. Totally we have currently 4 2 cross 2. So first 2 cross 2, which one is maximum value, it will take in the first set. And then second 2 cross 2 matrix, which one is highest value, it will take the maximum value. So at last we can have the uh, we can have the 2 cross 2 matrix. That is the max pooling layer. It will completely extract from the features. That is the max pooling layer. Fully connected layer is a last layer. It is classification layer. Whatever we have provided the data, then it will at last we can it will give the result. So based on the labels, for example, image recognition. So cats and dogs are there, then it will extract the feature. A cat has separate feature and dog has a separate feature. It will extract the features, and at last it will give the outputs. So this is the cat, this is the dog, like that. It will give. So I have explained in this last slide that computer vision basics means what we are going to do using deep learning. One is image classification, another one is object detection, another last one is segmentation by face and gesture recognition. Image classification means already I have explained in the last slide. Then get whether the cat or dog we have differentiated. Then object detection, anything. Say in case of trees are there, then we can immediately detect. So tree and humans are there, we can easily detect. So human, we can able to easily detect based on the feature action, based on the movement we can easily detect. And then trees can't able to move, that we can easily detect that object. Segmentation is nothing but if we are going to do any image processing TTLs, it will segregate the segmentation. For example, uh, in the road, cars and humans, everything will be there. So markets, everything, we can segregate the color wise. For trees we can give it a pink. Then roads we can give separate colors. And markets, buildings we can give separate color. We can separate each and every items. Whatever we have provided the inputs, we can segregate based on the inputs. Trees separate color, then road separate color, and then human separate color. Based on the movement, it will detect the buildings. It will detect the separate colors. Also, already I have explained that based on the label data. So this is the label data we have. That for example, I am telling. So this is the labeled data. So we have some images in prototype projects. So then labels we have already: cat, frog, dog, docs. And it will go to model training. I mean feature extraction, input layer and hidden layers. In the hidden layer has many layers. max pooling layer here, fully connected layer, and feature extraction layer, somewhat lots of layers inside the hidden layers. So it will automatically extract the features and give it to the fully connected layer. So the name named as a FCL I have mentioned as a. Then fully connected layer, it will classify into part of based on the features whatever we have provided the inputs, based on the input feature extraction. Then it will separately divided into one is called dog, another one is cat. It will predict. These are the labels. These are the label data already we have trained, and then this is the testing data. This is our input. So it will divide into dog and cat. Anyone has any doubts about deep learning? Hello, hello, sir. Naveen sir. Anyone has any doubt on this? Hello, Karthikeyan sir. Can you hear me? Hello, hello, sir. Hello.
Sir, your voice is audible.
Oh yeah. Okay. Do you
Okay.
have any? Okay. Okay. Thank you. Thank you. Okay. Okay. Next, how they connect, next I mean, how we are going to connect with the computer vision and deep planning. So we are going to give some original input, I mean, like that. So this is the original input for the deep planning algorithms. It will segregate based on the as a ResNet. This is a residual network. It will divide into parts. So based on the, see, we know already RGP, how they will work. Whatever we have provide the image details to, I mean, Python. We can do Python or MATLAB. We can do deep learning. It has available default libraries available in Python and MATLAB also. It will take the matrix wise. So we have 0 to 255 values. So it will divide. So based on the color, it will divide in the matrix wise. So then it will take the feature extraction based on the input matrix values. Then it will extract the features in the numerical values. Then we can able to, then we whatever we can give it the test data. Then we can go with the outputs. These are the, as per the current time, these are the application. One is tumor detection. I will show you later. I have the example data. I have done past project. Then I will show you. Then autonomous vehicle detection, scenes understanding whether it is driving or stopping, whether it is going, the moving. We can able to detect. And the visual search also, it will be there. Retail, I mean, some markets. What are the items we have? We can segregate it in the market side. Then we can easily can able to understand based on the image processing. We can able to detect the details. And security, facial recognition, as we all know that it will use some other places, colleges and IT companies, everywhere they are using based on the base recognition, whether it is at whether it is available or unavailable. We can able to design. These are the applications based on the AI. So I will, that is the ResNet, deep residual it's the deep residual networks, and then VIT, vision transformer. This is the processing. So vision transformer architecture. So already I have told you, this is the images. Then it will go to the deep learning process. So this is the layers what we have to do. Send feed forward network, neural networks. So what it will do, then it will, once we can given the data, then it will extract the features based on the inputs, the one segregated. A max pooling layer, it will segregate based on the features. So if humans will be there, then it will take the features. Automatically it will take the features. And then roads will be there. We can already trained program will be there inside deep learning, deep neural networks. Then it will take it will segregate the based on the labels. So this is the humans, this is the buildings, this is the gates, like that. It will segregate it. This is the classification of deep learning concept. I will show you what I have done in the past side. So this is I have done based on the skin mode disease I have used for skin mode disease. I will show you the data sets also. Here I have the data sets. Uh, uh, this is the data set. This is the image processing. We have in the skin somewhere we have detected some issues. I mean, this is a disease identified. Here, the disease identified. This is a normal skin. This is a disease identified spot. We can easily segmented the disease. First, we have segmented. Is this is where that disease affected spot. We can easily segment it. So rest of the pot we can maintain as usual. We can maintain the where this is identified spot. It will segmentation automatically. It will segment this pot. Then it will give. So this is the as a I mean disease name. We have the segregated the each and every things. I can these are the labels AKIC. Then this is each and every pots. It's a disease items. Do you have any doubts on this? Things? Hello. Hello.
Yes, sir.
Any doubts, sir? Deep learning is completely part of machine learning. Machine learning has many separate many things, but deep learning is a it's completely subset of machine learning. So it has a minimum number of feature, minimum number of layer. I mean, minimum number of things. I mean, machine learning has a lot of features like that unsupervised, supervised learning, SVM. I think decision tree, a lot of things. But deep learning has input layer and hidden layer, and then output layer. In the hidden layers many future extraction will be there. There's things that are max pooling and then fully connected like that. CNN convolution neural network layers will be there. This is the minimum things of deep learning. Anyway, it comes under machine learning only. So deep learning is a small part of machine learning. Sir, please ask me any doubts. I am ready to answer. But hello.
Dear participants, you have any queries in the duration of session, you can ask now, please.
Because deep learning is a minimum things only. Deep learning contain minimum part of things. So machine learning we can go large. Then deep learning is a minimum things only. We can use large number of data in deep learning. So we are going to use for deep learning GPU and TPU. Tensor processing unit, and then GPU is a generic processing unit. It will take it will take more time to data set read. So we can go with a high end processor for deep learning. Otherwise, it will get somewhat crash or it will create. Deep learning we can use it MATLAB and Python also we can use it. Both tools I have used in the past. In MATLAB we have the default structure also there, and Python has a TensorFlow and Keras we have for deep learning. So we can use that packages, both packages for in Python. Then MATLAB we can separate features, IM read like that. We can have deep learning packages inbuilt. Then we on Python side, Keras and TensorFlow we can use it. Basic things IM images read we can use IM. Whatever I have done in the past, I shown in the Python code. This is the Python code. Do you have any? Hello, sir. Team. Naveen,
Yes, sir. Yes, sir.
yeah, no one will. I'm ready to answer. You can ask questions. I'm ready to answer. I have
Okay,
experience. I'm
okay.
planning. Please ask.
Sir, or else better we can go for in the last session, for we
Uh,
can ask the question and answers.
okay.
So better, sir.
Okay. Last lesson means when
Which
tomorrow.
means, sorry, last in the sense you have after completing your presentations.
Yeah. That I have completed.
Yeah, yes, sir.
Yes, that only I have asked the question. That's all. Yeah, deep learning contains so minimum small part of things that so that hidden layers and input layer, output layer. That minimum number of layers only will be there. That
Sorry, your PPT is not visible, sir.
yeah. Okay. That's that.
Yeah, visible, sir.
Okay. Want to ask any questions? Please ask. I will. I'm ready to answer. Hello. Yeah. Please start your queries. I have completed. Please can start.
Dear participants, who have any queries, kindly ask me now, please.
Excuse me, sir. Sir,
Yes.
in unlabeled data, suppose we are predicting machine failure. So there will be a large amount of unlabeled data. So what should be the method or what should be the algorithm will be used in that type of thing?
This is for you. You are asking about data science. We have data science. I will. Wait, sir. So if image classification means we can it will go with we can go with the CNN. So convolution neural network we can go with directly we can go with in case of some Excel kind of data sets we can directly go with a recurrent neural network. We can proceed. It will take automatically. It will take. See, machine learning has separate feature extraction algorithms, but deep learning has inbuilt algorithms, inbuilt feature extraction algorithms. So we can go with a large number of data sets. It's not an issue for that.
Okay, sir.
So machine learning has separate algorithms, are like that. Decision tree already in the past session, Adalarasu sir explained clearly. So decision tree, K trees like that. We have separate feature extraction algorithm. So even classification algorithm also we have separate algorithm for machine learning. But in the deep learning, we have inbuilt algorithms like that. Already I have explained. We have the layers. So input layer, hidden layers. So we have many number of hidden layers in the deep learning. So output layer, it's a fully connected layer. It is a default, fully connected is a default. So we have a large number of hidden layers. So when we are going to do in deep learning project, we can increase layers based on the project. We can increase layers. So we have minimum number of data. Then we can go with minimum number of hidden layers. If we have a large amount of data sets, we can go with a large number of layers. So compared to machine learning and deep learning will give the more accuracy compared to machine learning. That is the point. So why we are going to deep learning, we will get the more accuracy on compared to machine learning. That is the point.
Okay, sir. Thank you so much, sir.
Oh yeah. Naveen sir, if you want my code, I will share with you. That's not an issue. That code is I have developed only. That
Yeah,
code,
please, sir. Please, sir. You can proceed, sir.
yeah, this code is developed myself only, so it's not an issue. If you want to share, then I will share. That is not a big issue.
Okay.
Okay. This is a skin tissues. I have developed this code is I have developed myself only. So using tensor and then keras for deep learning method, I have developed myself. If you want to this code, then I will share with you. That is not an issue.
Okay. Okay, sir.
I have used ReLU layer. That rectified linear image I can use for feature extraction. Anyone has any queries from your side, please ask. I don't. I'm ready to answer, but people are still. Naveen sir, no one has no queries.
Sir, it's hello,
Right.
hello, sir. Sir. Yes, sir. Please.
Yeah, any queries, please ask me. That
Yeah.
people are still silent.
Yeah. Dear participants, you can have any questions and clarifications. Kindly ask me now, please.
Naveen sir, do you have any queries? You can also ask me. That's not an
Okay.
issue. I
Yes.
think we meet. I think so. Somewhere. I will show my face. It's not an
Okay.
issue. I will show my face.
Yeah, I remember it, sir.
Yeah, okay. I
From
can.
SASTRA, from
Yeah,
electrical
yes,
four-wheeler. Yes,
yes,
sir.
yes,
You are
yes,
from
yes,
jury. Yes, sir.
yes, 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 yes.
Nice to meet you, sir.
Yeah, nice. Okay. Yeah, yeah, yeah. Are you can you able to understand what I have explained in the deep learning? That is not a big thing. So deep learning, if you think it is a hard, then we can anyway it will take complicate. So if we think easy, then we can proceed whatever we have to do. Then we can use it a deep learning. So machine learning is a whole thing. So artificial intelligence is the main part. Then subset of machine learning is a subset of AI, and then deep learning is a subset of machine learning. So it's a small part of AI.
Oh,
So inside it's a small part of AI. So it contains small things. Then only I have explained. So it has only input layer and hidden layers, and then output layers.
okay.
Okay.
Sir, actually, from question chat box, there is a question for
Uh,
a small set of data, how the results were vary with ML and DL, sir.
That's completely accuracy. Completely accuracy. See, for already I explained some more questions. The machine learning, we have separate algorithms like dysentery and then SVM, like that we have. After that, once feature extraction is completed, and we will go with separate algorithm for classification. That time we have minimum number of accuracies. I mean, like that 88 percentage or 90 percentage accuracy we have in the ML side. If we are going to use deep learning, we will get more accuracy because of we are going to use more number of layers based on the data set. Uh, Based on the data set, we are going to use a small number of data set. We can use just until 10 to 12 hidden layers we can use it. If you have small number of data set, you can go with 3 hidden layers. See, first layer it will extract features, then second layer also it will get extract, and third layer also it will get extract automatically. So that is the concept. But machine learning, we have a specific feature extraction. That is the difference between deep learning and machine learning. So we can have the specific feature extraction algorithm, but deep learning we can have the in automatic feature extraction with hidden layers. So it will completely based on accuracy. It will be more. Precision allow more. It will get, I think, 97, 95, 96 like that. Deep learning on machine learning we can get 88, 89, 90 like that. It will get. That is the difference. Okay, how to decide on the number of hidden layers? Based on the data set, we can decide, sir. So you are going to use more number of data, we can go with large number of hidden layers. If we are going to minimum number of data set, small data set, we can go with minimum number of hidden layers. Based on the data set, we can go with the layers. That's not an issue. So if we are going to large number of data set, for accuracy we can go with maximum number of hidden layers. Yes, yes, correct only. Then we have many number of hidden layers. Then it will give the feedback to fully connected layer. It is a lost layer. It's a lost layer. So fully connected layer will decide based on the feature extraction. Then it will decide. So this okay, the already it will feature will has been extracted and via hidden layers. Based on the feature extraction, fully connected layer will decide. So that is output layer. It will decide. So based on the hidden layers, it will decide that accuracy will be more than. For example, I will show you. I will explain. So a dog and cat also there. So dog and cat, it's same feature will be there sometimes. So that feature will extract in deep learning. It will be more useful for us. So in machine learning, it will sometimes it will get false. So we don't have the specific feature extraction for. So if we will go to machine learning side, we can more number of feature extraction algorithm we are going to use in machine learning side. In deep learning, we can't able to we cannot use more number of like that feature extraction algorithm. We can inbuild algorithm. We can have the inbuilt algorithms, so we can go with based on the hidden layers. Okay, thank you, sir. Thank you for your query.
Dear participants, if you have any other questions or clarifications, please. Easwaran sir, can you pick any other topics or maybe go for further agenda, sir?
No. I have only deep learning and computer vision.
Okay, okay, sir. Okay, sir. Dear participants, if you have any queries, or otherwise we can go for formal vote of thanks. So next session start with 2:15. Sir, Easwaran sir, shall I go for formal vote of thanks?
Okay, then I will answer Tanabal sir questions. One more question I will answer. Sir, you asked it right. We can feature extraction for a decision tree and SVM something. Okay, my screen is right. Screen got struck. Okay, sir, I will explain one more thing to you. So, sorry, my screen's got struck. Okay, I will explain to one more things. For classification purpose, we can use logistic regression and then naive bias and naive bias and k nearest neighbors we can use for classification things, and then feature extraction we can use for decision tree, like that we can use for machine learning. We can use separate algorithm for classification and feature extraction, but deep learning we have inbuilt hidden layers for feature extraction and classification. So that is answer. Okay, Navin sir, you can proceed.
Okay, sir. Yeah, again, good afternoon, Anandal. Thank you for the given such a wonderful lectures in the topic of deep learning and computer vision, sir. Thank you for joining the session, sir. Thank you, sir.
Yeah,
Mr.
yeah,
Easwaran, sir.
okay. Thank you for giving me the opportunity. This is my first session, so
Okay,
thanks, sir. Thank you.
thank you, sir.
Okay, thank you.
Dear participants, next session will start sharply 2:15 to 20. So you can join with the session 2:15 p.m. Thank you.
Yeah, okay. Thank you. Thank you.
Thank you, sir.
Okay.
This meeting is being recorded. So, shall we go for a formal welcome address, sir? Good afternoon, everyone. It is my pleasure to introduce our distinguished resource person, Mr. Jayakumar, sir, an accomplished technology professional with expertise in digital signal processing and advanced engineering systems. Sir is alumni of Indian Institute of Technology, Bombay, so one of the country premier institution for engineering education and research. His strong academic foundation, combined with extensive professional experience, has enabled him to make meaningful contribution to advanced technology development and engineering innovation. Based in Bangalore, he has built a successful career in technology-driven industries where precision, analytical thinking, and innovation play a critical role. His primary area of expertise in digital signal processing, a field that serves the backbone of numerous modern technologies, including communication system, embedded platforms, audio, image processing, artificial intelligence applications, and intelligent electronic systems. Throughout his professional journey, Mr. Jayakumar sir has worked a challenge engineering problem and contributed to the development of advanced technology solutions. His work demonstrates a strong commitment of technical excellence, problem solving, and continuous improvement. His experience allowed him to translate complex theoretical concepts and into a practical solutions and deliver the value real world application. In addition to his professional achievements, he actively participated in technical communities and professional networks, encouraging collaboration, innovation, and knowledge sharing among the engineers and researchers. His passion for learning and technology advancement has earned him a recognition among the peers and colleagues. So, with this short note, I extend warm welcome to Mr. Jayakumar sir and thank him for joining this session today. Welcome, sir.
Thank you all. Okay. Good morning. Karthik, good morning. Is it audible?
Good afternoon. Yes, sir. Yes, sir.
Yes, sir. Audible, sir.
Yes, yes.
Screen is
Very
visible,
good.
sir.
Thank you, Madam.
Yes.
So, thanks for excellent introductions. So happy to be back in KIOT. Almost 2 years back, we did this one similar thing. And also, thanks to Dr. K. Visakavil, principal of KIOT, and thanks to Sanmugam sir for putting things together on these occasions. And also thanks to Karthi, put a lot of effort to bring up from my side. I can see it. From our side, we have Manoj Kumar. He'll be online. He already logged in and seen. And then we have Spurti from NIT Trichy. She's our intern. So we are three people working hard to make things better for you in these sessions. Of course, we brought out good things for you. Presently, what's going on the ground for AI. Well talked about it, and also thanks to all the faculty members who takes out time and then coming out to this place and looking forward to engage professionally and also meaningfully to move ahead. Not only them, they have to make a move ahead of their own students as well. For all of you, thank you so much for coming here. And once again, in thanks to so it is extremely important to thank sponsors IST and PNY for providing this 6-day online faculty development programs on smart machines 4.0 intelligent monitoring and digital twin data driven engineering. Of course, we are all entering to the AI era. In these smart machines, the word smart machines sometimes become intelligent machines. Intelligence also, smart way. Things are happening around which you would have seen that. I'll take you around what we have, but in our thing what we believe in particular personally I believe will developing nations remain consumers of AI systems, consumer of AI systems or arise as a creator of industry ready architectures or advancements and research. Why this question is comes is important thing is the professors and faculties and in particular junior professors, of course the senior professors might be gone out of energy and then focus on management and like a commercial side of things. But the junior professors, junior team will have an opportunity to contribute, create the histories. So there is again I want to come back to the same slide. Is we have a like kind of a bouquet of district presentation today. I'll take you through around another 20 minutes maximum, and 15 to 20 minutes maximum. So I'll provide the platform in which how the things are unfolding after that. The two important presentation will be coming up. Spurti will follow after me. She'll be taking. She's working on advanced edge AI system called Ethos ARM Ethos U85 E8. She'll bring up and create the presentation from their side. She's working hard on that. And the third presentation from Manoj Kumar. I is a kind of expert in this driving up. We did create amazing sessions in hand, in person session in April 9th and SRM Katanglathir campus. It was interesting things where a lot of students were participated in that. Apart from faculties, we went on doing certain how to deploy AI, how to deploy AI onto the edge. That was a kind of objective which we had only one objective. That objective which we could demonstrate with the meaningful tutorial. So that's what Manoj going to bring you in details Of course, I'll be around. I also will be listening to them. Actually, every time I listen to them, then I'll find a better way to do next thing. So I'll be listening to him also today. The primary objectives are only one objective is deploy AI at the edge. So in this, deploy AI at the edge. Uh, bring up a lot of opportunities for industries. Of course, industries opportunity means academics also have kind of a good amount of opportunities. Apart from that, opportunities bring a lot of challenges. And the challenge is it's across the domains. It is not in a one vertical domain like a programming and coding and so on and so forth. It's bringing up the kind of smart systems. Suppose a drone, it's a smart systems. If you want, it has to be autonomous. It has to work. It has to do mingle with electronics and software and everything. On the top of that, we need to have intelligence on it, correct? And the most popular one, of course, all of you would have heard about it if not had driven a Tesla car. The Tesla car has it's a mix of all the things together. On the top of that, they have intelligence also for autopilot. Instead of human being driving the car, the autopilot drives, ADAS systems drives, autonomous system drives itself, and then human just travel that car and then board it like Uber, one place another place goes on to that. These are all happened. It's not happening. It's happened in West. That's what I'm telling. In the West, it happened. It's a reality actually. It's a reality. It's happening around, and car industries, the kind of industries who did not follow the AI and associated intelligence, they will fall out. Even Volkswagens fall out. You would have read it. General Motors, they're all catching up. Many the newcomers like Tesla is like giving up the task for them to follow it up, right? So even inside a developing nation itself, many car companies not gone through AI, they fell down. And also the company like Intel who did not go through they also fell down. There's a quite amount of things happening in the developing nations. Of course, our nation is quite calm. Nothing can change. Our nation is so big, 160 crore people. I don't think anything can change our thing quickly. But here and there are smaller bubbles can create a storyline innovation. So we are all in the smaller bubbles. We might get killed or we might get sidelined or anyway. But however, as the smaller bubbles, we create innovations. That's the part of the team which we are now actually. So in this, the one objective which again coming back, it is sure is like another 5 minutes. I'll take it in that 32, 12 minutes of it, right? Yeah. So if you see the one objective, I look at the kind of complexities required to put. Imagine in the run a model, a website, if you want to put a AI onto the, for example, even the mobile phone, how difficult to put a AI into that, it's like a website. You need so many dependencies, it's called like the TensorFlow, PyTorch model, ONXS, DF Lite, and you can read it full and full website, you see. So that's become essentially challenging for it's one engineer or one team, master all the website thing, and that create a kind of challenges for these third world countries who doesn't have infrastructures, everything in place to make things fine. Of course, even developed countries also have issues with some of the companies who doesn't have infrastructure to do all the things. They cannot succeed in going with the random model, right? But that's what it driven me almost 7 8 years back 2018, late in 1859. I was deeply into the issues of deployment in embedded engineer. As an embedded engineer, I had that idea to get how to deploy a deep learning model into this one. So the consequence of this, we worked, of course, not funded by national or CSA lab or something, homegrown, family funded kind of platform called Real Train, in which we wrote it completely native CC plus. Of course, me and my son. Of course, now new teams are joining with us, youngsters are getting over there. So it is completely written CC++. It's Node Python, TensorFlow, PyTorch, and so on and so forth, like a fin. And that C++ could go into standard on the libraries that create kind of for us is a smaller in size, fast, portable, easy integrations, and a production ready. The beauty of is it's homegrown in India. Of course, this can be truly made in coded in India, designed in India. Of course, deployment all over the world. So here we don't need a dependencies like a thousands and thousands of dependencies. What you was telling in. Uh, Another is, suppose if you want to put a CNN in Android devices, if someone of it tried, did anyone try this exercise? In case if you would have tried how to put a convolution neural network on this phone, mobile phone, you know the challenges. If you would have tried, in case you would not have tried, it's everything easy, right? Because in this world of reels, world everyone just YouTube and reels, everything easy for the present generation people. Actually, if you really honestly tried it, then you know the challenges around how to do this. We'll address Manoj will be address this problem how to run a CNN Android device. So this one, Manoj and me were tried this one with younger generation students and faculties in SRM April 9th. It went through successfully. So hopefully the same thing will repeat it today. So this was that one which we talked about deploy at the edge. What we are going to deploy AI. So, most of you are aware of that data model optimization, deployment, digital twin. These are the things that are part and parcel of one of the thing, one deployment. Training and so before going into embedded devices and things, we do have a stage called AI model. How do you train them? Then after that, we go and deploy them. The deployment, this part is reasonably easy in the server side, but the things have become extremely challenging in an embedded device because memories and so. But and also the silicon in the embedded devices are multi functional silicons and they were all complex. For example, if you say microcontrollers and then NPU, neural processing units, digital signal processor, field programmable gate array. These are all is a kind of semiconductor sits in the device edges, and of course TensorFlow, light, quantization. So the quantization runtime device drivers, these are all scary. That's what which we talked about it. So the challenge here is, and I should not say hundred thousands of dependencies. In fact, hundred is good as even we can handle thousands of dependencies to get this thing done. For example, quantizations related tools and framework related tools and drivers. Driver is a vendor locked one. I'll show you like here we see training of CNN Python 20 lines of the code, which you take it too many things like training, expert, conversions, quantization, runtime, hardware, drivers. Here is a vendor SDKs. That will be like a validation. It's a long process. Sometimes it will be frustrations, like a blame game. Customer may not agree that it's working as a delivery. A company might feel that they have done the work because there is no ISO standard, there is no ISO standard such as this is what the performance is expected and so on. So these are all newly evolving systems. There are no IEEE standards as well for model. Whatever we done is that. That's the end. Of course, sometimes I feel working in advanced things. I used to enjoy this kind of happiness, but associated things, educating others become extremely challenging, particularly in India. It is not easy to go and educate the customer and sell the product because you're more of trading community. They buy and sell, or something and sell. So in the absence of design and development R&D, it's extremely challenging to go and tell them all the complexities what we do. So here the drivers are come from vendor SDKs. Every vendor have their own, like Qualcomm has their own system, they call ST Micro or MediaTek, all the thing. That's a place we trying to bring the whole thing is quite nicely to in our thing. If you have a kind of C source code and everything available with us, then run with a particular compiler of your DSP and so on and so forth. This is what which we are brought out, designed very nicely, working well. Manoj will take you around. So I think another 20 minutes, another 5 minutes have. And so, what is the life beyond TensorFlow and PyTorch? It's zero, correct? If we take any data science AI engineering student or faculties, with them we can't see anything outside of TensorFlow and PyTorch. They said zero, nothing is existing. But carrying these two things into smaller devices, carrying like a huge of 200 kg of load in our head, which is impossible for a human being to carry. So this exactly how do you carry this TensorFlow PyTorch into the embedded devices is the one that we thought about beyond TensorFlow and PyTorch. That's what which is viewed is the different approach. We need a different approach instead of what is beyond with a different approach is essentially edge native. There is something native to the edges. We work with those tool sets and make them to be more beneficial for us to quickly and this. That's what we talk about it. Edge native AI development. Manoj will take over about it. Even Spruti will talk about on E8. When I thought. Another 4 minutes I have. So this one example which is there, Manoj will do much better than that. These are all in the what do you call the whole thing, whatever presentation it is, you can actually go and access in your computers. I can put it in the it is there in the things. It's not a PowerPoint. It is there in the computer. You can access jqs.com. So this is a place which is Spooty going to talk about a deployment roadmap. Of course, it has so many steps from thing, and this she will be taking you through. So what happens is today the maybe the detailed things of Smriti going to do that. But I want to add a bit of the silicon side information. In the ARM Ethos U85 is a new generation semiconductor. Of course, uh, today Karthik announcing about me did not mention. I think I'm also ARM ambassador, which I work hard. Kind of thing. In this ARM Ethos EU85 is one of the upcoming processor expected to be in the phone, which has a U85. It's like a NPU. It has a 512 cores of equivalent of neural processing units called NPU, which has the CPUs and also NPU also. Now the AI part will CNN is going to run in NPU's part, other OS and GUI running on this one. And this is a kind of new IP coming from ARM for AI alone. It's good for Edge AI in particular. The Edge AI can come into the different form and shapes. It can be in the car, it can be drone, it can be camera, it can be in our even a known computer actually. It's like we don't need to go to server and so on and so forth, which we can do it ourselves, that kind of thing. It's very popular in the defense side, in the radar or what do you call machines. I don't want to get into that. So the defense people also are trying to use it, but it might take time. But advanced countries, they do use this one very well. It's ongoing war between few countries, how it's drones going and taking care of many of the things. Right? So with this, I think I plan 25 minutes exactly. I have 1 minute of the time things. So with this, I think. I'm done the basic intro into this to welcome the younger team to present to you. But our objective is deploy AI in the edge. Without AI, what happens is edge is a well known industry, like called embedded industry olden days. Then it become IoT industries, next generations kind of thing, industry 4.0. Then it will become a smart machines and so on and so forth. But now it's become more commonly called edge systems, and particular AI. Edge system can be for communications or entertainment, even Alexa under one kind of edge system in your home, like a Fitbit on our hands, kind of edge systems. The edge is going to be carry the AI mean there's a new opportunity, new hardware, new talent, new innovations required. Of course, a good amount of funding also required without extremely challenging to use the powerful, intelligent team of people to get over hardships. Else we will be circling like a frog in the well. By then, Western world will be go deep, very far away in the research. We will end up keep buying from them or begging from them. That's the way India have been. There in this stage, of course. As of today, including we have so many IITs, NITs, nothing coming out of this world in terms of concrete framework like Python or like TensorFlow or PyTorch. Nothing emerging in big country in India, but we are independently we are put up. The TL trial, which is the one is available for you all, which you can use it, and also you can find a way to improvise it more and more if you want, but it is available. With this, I think I will invite Spruti to take over.
Yes, sir. Am I audible?
Yeah, you are audible.
Yes, sir.
Audible.
I'll share my screen.
Okay.
Let me stop sharing. I did the stop sharing.
Yes, sir. Okay, I'm not able to share my screen because
Uh,
I'm an attendee.
now wait a minute, madam. We'll make a co-host, madam, with a minute.
Yeah, yeah, okay.
Madam, you can try it, ma'am. We make it as a co-host.
Yeah.
Okay, good afternoon, everyone. My name is Purti, and I'm a BTech student in NIT Trichy. So I'm going to take like 10-15 minutes to sort of walk you through the Edge AI deployment on Ethos U85 NPU. So basically, the natural question to start with is why run a neural network on a tiny embedded processor at all? Why not just send the data to a cloud server and let it do the heavy lifting? So, the conventional model for deploying AI has always been cloud centric. And this works perfectly well in many scenarios, but it breaks down whenever you need like ultra low latency or you're in an environment which has no reliable network connectivity or when the cost of transmitting raw data continuously is simply not feasible. So Edge AI solves this by moving the intelligence directly onto the device. So instead of uploading data and waiting for a response, the microcontroller itself classifies, detects, or predicts in real time, locally without any network dependency. And the key insight here is power. The ARM Ethos U85 MPU is specifically designed to deliver this inference capability at under 1 milliwatt of power. This is what makes Edge AI viable in battery-powered IoT devices. So this is sort of like the workflow of like till where I have done in the project. And like Sir said, DL train is more efficient, but since I'm relatively like newer to this, I've used TensorFlow. Um, so like we use the MNIST dataset, which has 60,000 training images and 10,000 test images of handwritten digits from 0 through 9. And each has like 28 by 28 pixels, and it's a single channel grayscale. So now let's look at the CNN architecture and like why it's structured this way. So the first convolution layer like learns very simple features from the image, such as like edges, curves, and corners. So after that, the ReLU introduces a non-linearity, which allows the network to learn more complex patterns instead of just simple linear relationships. So the max pooling layer then reduces the image size, making the model more efficient while also helping it recognize a digit even if it's slightly shifted in position. The second convolution layer builds on the features learned earlier. So instead of just detecting edges, it starts recognizing combinations of those edges and shapes that are more meaningful for identifying digits. So another pooling layer further reduces the data size while also keeping the most important information. So once these features have been extracted, the flattened layer converts them into a single vector. So the dense layer then learns which feature combinations correspond to each digit. So finally, the softmax layer produces probabilities for all 10 classes and selects the most likely digit. So overall, this is a simple and lightweight architecture. It is powerful enough to achieve high accuracy on MNIST while remaining suitable for embedded deployment where memory and computation is limited. So next comes training and quantization, which is the stage that transforms the CNN from a model architecture into something that can actually make accurate predictions on new images. So during training, the network repeatedly processes thousands of handwritten like digit images and compares its predictions with the correct labels. So any prediction error is propagated back through the network, allowing the weights to be adjusted so that the model gradually becomes better at recognizing digit patterns. So over time, the convolutional filters evolve from random values into feature detectors that capture the visual characteristics of each digit. So however, the trained model still uses floating point values, which are expensive in terms of memory and computation for embedded systems. This is where quantization becomes important. So the idea behind quantization is to represent the same learned information using 8-bit integers instead of 32-bit floating point numbers. So to do this, TensorFlow Lite first analyzes a representative set of images to understand the range of values that appear throughout the network. It then computes scaling parameters that allow those values to be mapped into the int8 range while preserving the behavior of the model as closely as possible. So by forcing the inputs, outputs, weight, and activations to use int8, the entire computation becomes much more efficient. The model requires less memory, transfers less data, and can execute like significantly faster on embedded AI hardware while maintaining nearly the same accuracy as the original floating point model. So the next stage is the ARM Vela, which is essentially the compiler for the Ethos U85 NPU. So even though the model has already been quantized to int8, it still exists as a standard TensorFlow Lite model. The NPU cannot execute this directly. So Vela translates it into a hardware-specific format that the Ethos U85 can understand. So to do this, the Vela first analyzes the entire neural network graph and checks the compatibility of each operation with the NPU. Operations such as convolutions, pooling layers, and fully connected layers can be mapped directly onto the accelerator. Vela also performs memory planning rather than just allocating memory dynamically using inference. It computes the complete tensor memory layout beforehand. As a result, memory usage is known in advance and runtime overhead is reduced, which is particularly important in embedded systems where memory resources are limited. So another optimization performed by Vela is weight compression. So since the model has already been quantized to int8, the weights can be stored more efficiently, reducing the amount of flash memory required without affecting the model's accuracy. Perhaps the most important task Vela performs is generating the NPU command stream. So instead of just executing high-level neural network operations, the Ethos U85 executes a sequence of low-level hardware instructions generated by Vela. So you can think of this in the same way that, in a C compiler, like it converts the source code into machine code for a processor. So Vela converts the neural network into instructions that can be executed efficiently by the NPU hardware. So next is embedding the model into firmware and building the software stack required to run inference and target hardware. So unlike the desktop system, the Cortex-M platform does not typically load machine learning models from a file system at runtime. So instead, the model is compiled directly onto the firmware image and stored in flash memory alongside the application code. So to achieve this, the TensorFlow-like model is converted into a C array using the XSD utility. This generates a source file containing the model data as a byte array. So when the firmware is built, this array is linked into the final executable, allowing the application to access the model directly from the flash memory. TensorFlow Lite Micro can then parse the model in place without needing any additional memory copies. So once the model is embedded, several software components work together to execute inference. So like the TFLM acts as the inference engine, loading the model, managing memory, and coordinating the execution of neural network operation. When an operation is mapped to the Ethos U85, the Ethos U core driver provides the interface between the software and the NPU hardware. It is responsible for communicating with the accelerator and executing the command stream generated earlier by Vela. So supporting this are the CMSIS libraries. So the CMSIS core provides access to Cortex-M processor functionality and the device startup support, while the CMSIS NN contains highly optimized neural network kernels that can be used for operations executed on the CPU. So finally, the board support package handles hardware initialization and provides the low-level runtime services required by the application. So together, these components form the complete embedded AI software stack, allowing a model that was trained in TensorFlow to execute efficiently on Cortex-M system with Ethos U85 acceleration. So the final stages are building the firmware and executing inference on the target platform. So the build process is managed through CMake, which acts as the blueprint for the entire firmware project. So it specifies the target Cortex-M architecture, compiler optimization settings, source files, linker script, and all the libraries required for TFLM and Ethos U85 support. So in a cross-compilation environment, CMake is also configured to generate firmware for the target board rather than just attempting to build and run code on the host machine. So once the firmware is built and flashed, the inference application takes over. So the first step is to initialize the TFLM runtime and allocate the tensor arena, which is the memory region used for all tensors during inference. So the model is then loaded directly from the flash memory and then used to create a micro interpreter, which manages the execution of the neural network. So after tensor allocation is complete, the input image is written into the input tensor as int8 data. So this application then calls invoke, which is the point where the actual neural network inference begins. So during execution, data flows through the convolution, pooling, and dense layers of the network, ultimately providing output scores for all tens classes. So the output tensor is then read, converted into meaningful probabilities, and a predicted digit is reported through the debugging interface. So this slide shows the final firmware build process. At this stage, all the individual components we've discussed are brought together into like a single executable image. So the application code in the J9 app.cpp, the embedded neural network stored in the model data CPP, the TensorFlow like micro runtime, and the Ethos U85 driver, CMSIS libraries, and the board support files are all compiled and linked together using the ARM cross compilation toolchain. So the output of this process is the j9app.elf, which is the final firmware image that will run on the target hardware. So inside this file, the application code, runtime libraries, drivers, and model are stored in a flash memory, while runtime data such as TensorFlow Arena, stack, heap, and global variables are all allocated in the SRAM when the system starts executing. So before deployment, we use the ARM non-EB size to check the memory footprint of the firmware. This allows us to verify that both the flash usage and the SRAM usage fit within the memory limits of the E8 platform. So by the end of the stage, everything required for inference, like the application, runtime stack, hardware drivers, and optimized neural network, it's all been like basically packaged into a single firmware image ready to be flashed onto the board. So to conclude, we've covered the complete deployment like pipeline for running a CNN on the Ethos U85, starting from model training and then quantizing into the int8 and optimizing it using Armilla, and then embedding it into the firmware and using TensorFlow Lite Micro runtime. So now the next step is hardware deployment, where the firmware will be flashed onto the E8 board and the first NPU accelerated inference will be executed on the Ethos U85. So before I finish, I'd like to thank Jayakumar sir for his guidance and support throughout this project. He pushed me to genuinely understand every layer of this pipeline rather than just executing the steps. So with that, I'd like to conclude my presentation. Thank you all for your time.
Pretty interesting, very well. So good. So of course, the younger leaders are going to take this one. It is well said. We have a E8 board. What Smriti was telling is one of the advanced processor ARM ethos U85 U85 onto that board called E8, in which we are all they are getting ready to go and use it. So a lot of preparatory work is going on. When a new board coming, new system coming, if we cannot go and touch that overnight. It is in fact in industry when a new board comes. For me, like imagine one board is coming like this, it will take months together ahead of preparations and then make sure the lead is growing. So this younger generation also getting a taste of it. It's good. They were all like focusing on a good thing. And this E8 board is available in Bangalore. If someone interested from KIOT, this faculty development program, who want to access it, we can loan it for 4 days, 5 days for you on that area. You can return it back. The bird is not available shared for commercially, but this for engineering samples. That's a place which we have. We can share with it. There is no money involved in that. Okay, so we're trying to get the ecosystem up and running. Of course, Prati is working on it. Few more answers also working on it. Their support also might be available for you all to in case to get on it. We have a next thing is this hard thing what Smriti and previewed for you is a very hard thing called like HA going onto the completely onto the NPU, neural processing unit. NPU is equivalent of GPU, so it's not named as a GPU. Okay, so coming systems with including mobile phone will have AI on it, that the chipsets are going to change. If any effort, if you put invest, that going to be very beneficial for you in terms of publications or in terms of open source tools. It have more than publication, and request all of you focus and make sure our source code goes much better, like we call like TensorFlow, Python, and things. In fact, when I was young, I seen how MATLAB is came from MIT Boston. In fact, MATLAB Chlef passed away 2 weeks back. One professor made a whole MATLAB working, collected student software from those days libraries. Even today, there was a joke on that. In C we have a zero index, like a C of zero, C of one, and so on. So, but MATLAB we had to start with one. So one of the guy RJ was asking JK that problem 30 years we had to take on our head. Then there was a view that that time the library is written mostly Fortran, so they put together and created a MATLAB initial stage. So that might be the professors who and the researcher worked on Fortran. They might have come into the MATLAB thing, so they kept that one in array starting with index one instead of zero. This was thing just when Chlef passed away. We were discussing that across the globe. Why this we got stuck with one instead of zero. So that was the thing. Now today, almost all the colleges, and researchers, industries do have a MATLAB and this thing. Of course, nowadays you do have a Python, TensorFlow, and so on and so forth. But those two things are appears to be not going from what you call it. Thing that's what TensorFlow like PyTorch, they have a thing. That's what today's Prati was told. In between, our friend now is going to preview the a real-time based deployment without any Python intensive flow thing, which is a very interesting, highly advanced one, which is I'll invite Manoj to take over the things.
Thanks, JK sir and Shruti. And I'll be sharing my screen. I'm not able to share.
Share one. But Priti, I had to unshare it, ma'am.
Sir, I'm not sharing my screen right now.
Sir, we will make it a co-host, sir, within a minute,
Okay.
sir. Yes.
Okay.
Yes, sir. Before start the Manoj Kumar session, I would like to communicate that welcome letters for Manoj Kumar sir. Formal welcome letters.
Please go ahead, my dear. Please go
yes,
ahead.
sir. Thank you. So good afternoon. It is my honor, privilege to introduce our esteemed resource person, Mr. Manoj Kumar sir. Is a visionary technology leader and accomplished industry expert with more than 24 years of experience, enterprises technology, digital transformation, and product innovation. Sir currently serves as a chief product officer at Mentis Systems and also associated with CTO in making at Cold Chain X. Throughout his destination professional journey, he has played a pivotal role in designing, architecting, and delivering the AI-powered and cloud-native platforms that have transformed business across multiple industries. His area expertise including artificial intelligence, machine learning, generative AI, cloud-native architecture, enterprises architecture, product strategy, cyber security, data platforms, edge AI, IoT system, and digital transformation. Sar widely recognized for his ability align technology innovation with business strategy. He has established the Center of Excellence, mentored startup founders like global engineering teams, delivered scalable solutions that create a measurable business impact. His leadership style emphasizes innovation, collaboration, and customer-centric thinking. With this short note, I would like to welcome our this session chief guest, Mr. Manoj Kumar, sir. Welcome you, sir. This session over to you, sir.
Thank you. Thanks everyone, and especially JK sir and Spruti and designated members. Let me share. Are you
Manoj,
able
your
to see?
video missing.
Just video. I'm not able to. Is it okay?
Yeah.
No.
Yeah.
Okay. So, lot you have told about me. My field was banking, and I converted myself in 10 years to a technical portion, mostly into software and architecture. So, thank you. And sir has given me a direction in Edge AI, which is going to be having a very good use case for future for India and in a global arena also. So, um, at present, I'm seeing a ecosystem and a cross business across different industry. So I'm at present also working for a cybersecurity for Aston University in London. So they are we are having a POC for that also, and I'm seeing a opportunity for Edge AI in many chips of data center as well. So let's see. This is the beginning. I'm excited. So I'll be sharing this what we have done in what we have done in SRM as well. So uh, most important, as rightly said, in a limited resource of edge, how you will be having the AI inside it. So and whatever industry you see, AI means Python, PyTorch, like that. So many dependencies are there. So and the deployment is the complex activity, and because it is a driver and other dependencies are there. So in this, using DL train repository we have deployed, and most important is you should have Git. I have done it with a Mac machine, but you can do it in any machine, Windows. The path will be different, but the essence remains same. So you should have Git. You should have a Java 17 Gradle for building it, and Android Studio to have a Android Studio to have a IDE for your your repository and
Sir,
respective SDK.
sir, excuse me, sir. Sorry
Yeah,
for the interruption, sir. Do you have any PPT, sir?
yeah.
It is not shared in the screen, sir. It
Okay,
was not
means
shared.
okay. Let me see. Are you able to see?
Yes, sir. You have to maximize that.
Just a minute.
Manoj, unmute it. Karthik, his mic is muted, I think. Oh.
This PPT is
Sir,
hello. The PPT
came
is
to
visible
making as
also.
co-host, Manoj Kumar, sir.
Are you able to see?
Yes, sir. Yes, sir. I able to see you. So now I can able to see you, sir.
My screen now?
Yeah.
Yeah,
Okay,
your
perfect.
video is okay, sir. But screen, you have to share the screen, sir.
Share the screen.
No.
Go to the share button.
You
Yeah,
can
it's okay.
all plus. Yes, you can. Okay, sir.
Yeah.
Okay.
But it
Yes,
is
sir, it is fine.
Okay. So in this case, whatever dependencies are there, I have created. Means to pull the DL train repository, we need a Git, and it can be any platform. It can be Windows. It can be Mac or Unix, right? The essence remains same. So you need Java 17 plus, and you need a Gradle to build it. 8.02, it is compatible with that. So I have kept it, freezed it. So you need a IDE, Android Studio, to do that. Android SDK, and to make a APK files, you need this Android debug bridge is there. So I will share. Able to see my screen, right?
Yeah.
Because the installation of Java and all, it will take 15 minutes. So I'm giving you sequence. So we have Git, and with version is there. So now Java. Install Java, because it is Mac. So we have used Brew, and we have installed Java 17. And you can install it using Oracle also. And automatically it will install all the dependencies as well. So we have Java 17 and related dependencies as well. So now what you have to do, since it is your environment, it can be Windows and it can be Mac. So you have to have a path and Java home set in your environment. And when you see to test it, you see the Java version. So it will give you 17 points, whatever you installed. Right now, it comes to have a Gradle. For our this J7 app, we have to have a building tool, which is nothing but a Gradle. So we have installed, means we have downloaded Gradle. And then you have to unzip it. It will take, it will be around 1.5 GB in terms of the size. And have the location for Gradle. So you put it, make a directory or and internal password and all. You set it up for Gradle home, and same what you did for Java. So see, the Gretel version has come, and now this tool is done. Now JK sir repository, a public repository, you also can download it from the location, and this is in GitHub, J7 app. Now that all ecosystem you have already created, now using Git, you just pull that, clone it, go to that respective directory, and we'll be having a means inside that application you go to and have a Gradle wrapper. Sometimes it will not have a wrapper. Just cross check it. As I did, a wrapper was not there, right? So in respective library, and you set up Android Studio, right? And this with the same strategy, you'll have an environment variable and path. So keep on sourcing this ZSHRC. In that, you'll be getting all the means dependencies loaded, environment set, and home path is already set for the project. So now you have the SDK, Android SDK already there. So when you say Gradle wrapper, so it will have a wrapper for that, and you will get all the SDK dependencies already there. So now what you have to do, finally, the aim is to create a APK file for deployment, because it has to, it is for Android only at present. We will be having for Unix, you will be having for other phones like iPhone also, but this is for Android. Just wanted to portray that this is for edge device, mobile devices, it is deployable. So because of the limitation of the device, edge device, you are not using it for creating, you are using for deployment, so that with the limited resources, RAM, CPU, it will be working there. So you put this in a debug mode, and then APK is created. So means it will go in a output file. I'll show you. See this. This is Android Studio, and because of the presentation there are multiple options to integrate with Android device. So one is you can have a debug on, and you can have a means a USB port open, and then you transfer the file, APK file. Another is you send the APK file in WhatsApp or any other channel, and you can just deploy it, accepting the risk. And third is I have created for demo a simulator, Android simulator. Same app will be working in Android. I can do it in Android Studio with the simulator on, and the same type of resource and consumption will be there. Suppose I write number 8, right? When I say go, it will give accuracy of the model, right? Suppose I clear, and it is deployed, means the same thing you will be deploying in Android. So I say go. So the means the probability of the model, it is showing, right? So 7 is 97%, so it is accurate, but 8 it was not. So in this way you will be finding way to optimize your model, or means achieve your accuracy of the model by this way. But the main idea is to have a deployment in edge device where now industry is moving. So in a limited resources, we are not going for Python or TensorFlow. We are going for C, C++, and where we don't have in a deployment any code written. I have not written single code. So this is where many use cases will be there. In future for E8 and ARM devices, and there can be multiple industrial use cases where AI is inside the chip, edge devices. So integration becomes easy and with the limited resources. So and we have done this in SRM with the help of JK sir, and now we are getting a lot of traction there. So we'll be signing MOU with SRM University, and it is in process. And I'm getting different calls for making it happen in different parts of India. So we are in right track with the limited resources. We are moving, and most important is with my background, because at present I'm sitting in some fund company. So they are also interested in our product going further. So we can go for a ecosystem where we will do cross business in different industry. This is what my previous experience is, and we can repeat it again with the India story, whatever limited resources we are having. So thank you, sir. And this is what I can means project. The future of our AI will move from GPU to edge devices now, and it will be industry practice. So for all faculties to have a in tune, we can have a micro learnings department or micro learning skill development, where no need for 6 months or 1 year of a course. So because generally universities are 6 year back from a technology perspective when the student lands on ground. So in that sense, if we do this kind of a learning to exit students, it will be very beneficial for them and the country as a whole. With that, I have time, but JK sir, any comments and Spruti? Thank you.
Thank you, Manoj. I didn't have comments. I did take a notes of it. Nice you emphasized and how to put a Java, 17 through Pro. I think you have a Apple machine which is there. Instead of that, we can have a Windows machine or Linux machine. Also, they can.
Yes.
Second thing, I think you went through the Cradle. You said 1.5 GB size, which is it is also downloadable. It is of course free. Third thing is you went our J7 app, which is available and hit up. Anyone can download it. The complete source code is free and open. Then you went on Cradle wrapper. You went on it, path setting and so and so. After that, SDK dependencies resolving, and then APKs how to create, and then how to use it also in the short time of almost like within 30 minutes. I think almost like 27 minutes you completed this.
Yeah.
Thanks for it. It's a good thing. In fact, we're looking forward to listen from faculty members, staffs, and who really want to put some of their what do you call versions of understanding, or if they have something else to share with us.
Exactly. Yeah, this will improvise us and give us a positive feedback and going forward, because then the gap will be less. Thank you.
The major difference between Manoj what presented is he did not use the Python and TensorFlow. He taken the model which trained by DL train.
Yes.
So that's the one important thing which he has demonstrated in front of you. There is no place Python and TensorFlow, PyTorch were been involved in to create, design, train, and deploy the model. Of course, Java is there. Java is for your GUI, not for
Yeah,
engine.
yeah.
And Java is meant only for a GUI purposes. If you don't want the GUI, you don't require a Java as well.
Yes, yes. You can do it with the command line. Yeah.
Like drone and all, we don't require a GUI, so we don't really, what do you call, Java and interfaces and Android. You can go with the native. That's a place what Spruti put up the things where she did not bother to anything on the user interfaces, so she did not talk about Java and things like that. She
Yeah.
directly went into the U85 Havela compiler actually. In fact, I would request to faculty, staff members, in particular younger members, to get along very quickly with Vela. The more quickly you get along, your contribution going to be phenomenal. Which I could see, 2000, 1998, 2000, 2005, what happened in world of audio MP3 player, which rocked whole world those days. You go to Google and search a three-letter word, the most popular word is MP3 those days. Now in the three-letter word become two-letter call AI now. Let's back into that. So the MP3 was going all over the silicon everywhere and that thing. That point in time I could see this kind of flourishing. Of course, I had a company those days called Epicon Media Technologies where we monetize and also we explored our a brand name across the globe onto that. I think this is a very good opportunity for us to go. We don't require billions of dollars in AGI. Unlike if you want to go to compete with OpenAI, I don't think India is possible at all. At the present condition of our hand-to-mouth budgets and things, we cannot go and compete with the Gemini or OpenAI or those people. Of course, we can compete with the AGI side. We can not only compete, we can create a better wine spend actually. This one thing, and thanks to Spriti also to brought out critical thing, new tools called Vela from Arm, which essentially makes a TensorFlow Lite model to find the home of U85. U85 is a processor. It's not open to program in C, C++ now. It's improving. Soon it will come back. So now the Vela is essentially doing memory allocations and a thread called finding everything it is doing that, and such that then ELF file directly can download it onto the board and then running. This is a very early stage, but it is a interesting one. It's just not only model; it's give a runtime environment also called TensorFlow Lite Micro (TFLM). So these two things are there. I do not know whether we could be able to provide you clearly with these short times. These are the things we'll go through 3 4 days of a kind of presentation with this 1 hour, 1.5 hour. We did try. So let us listen to the people in case Pradeep is not having anything. Pradeep, do you want to add something? Did you miss something or do you want to add it?
Not, I mean, nothing specifically, sir.
Then let us listen to the faculty.
Yeah. Any other questions from the faculties you can ask me, or we can go for a vote of thanks. Okay. So
If not,
yes.
there is a platform called Mentis Scholar where it
Okay.
is a LMS, learning management system. We have a course in that. Similar course will come. And the advantage of that course is you can have a on demand cloud or CPU. So the student will not have to uh, have a specific laptop with the higher capacity. You can have a GPU or CPU on demand. So you will be having a course in which practical can be done or experiment can be done on demand on GPU or CPU. It will be provisioned um, whenever the assignment is going to come, and you can have a assignment which can be accessed by
Jayakumar, Manoj.
Some
hello.
question is coming, I think.
Yes, sir, now you can.
Yes, Karthi, are you trying to talk something? A cross talk or something?
Yeah, no, sir, no, sir.
Yeah.
So yeah.
Manoj is trying to give a briefing about the platform which is completely built in India, okay? Very
Yes, sir.
recent one called Mentis color. In that, whatever most of the time we go to physics lab, 12th standard or 11th standard or chemistry lab, afternoon we go to lab, teachers and professors, they look, set up they give the apparatus and an instruction to for experiment, they'll go off. So as a student, we have to use that apparatus for another 3 hours, and then do our physics experiment, and also write notes, not only notes and the report. At the end, we have to submit the report and then go out. That's where the physics, chemistry, or biology labs are done in undergraduate, sorry, school days. Even undergraduate also same. It's nothing much different actually. But when it comes to AI things, which is a problem, is we don't have high capacity GPUs, we don't have this and that in our place. Our management doesn't buy those things. Then so literally our young generation cannot run like Manoj just put summon and then asking inference in front of you, correct? So such kind of things doesn't. Of course, you can go to Colab and try to do certain things, but we come for edge AI, which you need to have a kind of a complexities to optimization, quantizations, and so on. So what Shruti was talking about it, Green. So those things are not done. Still download it onto the board and then see whether it's working or not. That's the place Manoj is telling that you can have meaningful exercise for 3 hours called microscaling. So that 3 hours, 2.5 hours, younger generation can go to lab with the guidance of professors, of course, and lab faculty, sub staff, and then complete the experiments. This is A experiment, right? A experiment. One was the -0 It can be your own data sensors also. Your own sensors, like 100 sensors and KIoT temperature sensor in the campus. So you want to find out what is the inference about the temperature in the campus or when going to rain. Suppose you want to do that one for a campus alone, you can have your own data set and still run in this kind of situations on that, like your car itself, you can put it. So this, you can construct this kind of experiments by using these infrastructures, 8 or 9 experiments per semester. That's one Manoj was telling that we constructed about 2 of them, and one is that J7 app. On the J9 app is cooking. That's what Smriti was talking. It will be another month or two. J9 also will come up with board. J9 will have with board. J7 which goes with your Android phone. So, and also to train those models, you don't require your heavy laptop yourself or things in the camp phone. You can hire for half an hour or 45 minutes. Manoj is coming with the new ideas to encourage the youngsters to use the good machines to GPUs to do those things also. That's the place we are done. This is essentially gives you kind of a method and apparatus to design a smart machines in which you can deploy AI.
Sure,
So
sir. Sure.
otherwise we cannot go and to put a chat GPT in our camera, correct? Imagine we put a camera in our car, we can put a chat GPT on the impossible. So but we can have a CNN in our own. So whenever you go and to open a door and the car should open. Whenever your family members comes, we can open. Someone else comes and open the car, your car door. It should, if you that it is not, someone else comes to open. These are the applications you can create it there as embedded.
Yes.
It is endless. It's quite. We can have a sensors in Mistral. We do things like memory radars, but if you do use that one for signing, like open ways, signing ways also you can create signatures. Actually, no need to get a face signature alone. You can have a signature, artificial signature in front of the camera. If we go and do something like this, suppose 3 or 4 times, that become password, correct? So it's not that we have only our face as a password. So things are happening around. So these are applications you can synthesize it and then put it in a lab. And many of you, I'm sure 35, 34 people are there. I think now in this 36 people, out of 36, 30 or younger generation, all of you become a group and hit up. Dear time, you're all welcome. I'll put you what do you call lab exercise. What I told this one. Use these facilities and train it, and that become a lab. So invite you to MATLAB like AI lab. Who knows? After 20 years, I don't know whether I'm not there. But those things will be useful for outside world. If we go to other places, luckily Shanmugam sir and our Chairman Srinivas, Srinivas and Visakha, these are the people roll out certain things in advanced things in this thing. If you go to down south or even down south Tamil Nadu itself, we not have seen this kind of perspective. But then even IITs also would not have thought about all this. You're all lucky. We have leaders who bother about things. It's a good, you are latched on to things early, and then construct such a OCN and conventional network which for your applications that can be a lab experiment. Like that 8, 9 of experiments we have, that will become a kind of a 3 months thing. When the youngsters do that, need not be all the 8 they do. Someone who doesn't like biomedical, they no need to do 3 out of 7. We give the option, they'll complete 3 and then go. 7 they'll give exceptionally good marks. You will walk in any company like a Google or IBM, they'll get selected. Some of them doesn't want to do that 3 out of 7, so they'll do the 3 experiment themselves instead of buying from outside. One pathetic thing was, I felt very sad 10, 15 years back. People market go and buy a projects called IEEE projects. I felt very sad, how degenerations in engineering education in front of me. Unbelievable. So those things we shouldn't, allow tolerate, because we have to create a good younger generations. Today we are all there because our faculty members worked hard. When I was young, MIT, all the professors will come. In fact, if you read Wings of Fire, Professor Kalam's, Dr. Kalam's thing, Wings of Fire, you'll say Kalam was doing that Friday evening, Saturday and Sunday morning also. Sunday morning, the person who went and seen this professor, I forgot his name, but Ayo, sorry. And the professor went and seen the student doing experiment or not Sunday morning in the lab. Imagine Madras Institute of Technology, what kind of level is that, which I see even university student also had seen. The same case in IIT Bombay also. I seen professors walking to the when midnight. Professor MC Srisalam couple of times came in the midnight and lab. This what happened? No, I did not know whether you guys could manage it or not. That's the kind of professors which is seen the same which I seen the professor in MIT Media Lab, also Professor Barry Webco. He gets into the thing and anytime any kind of thing. It's a 24/7 for him. Not even like no day and night. These are the professors given us the amazing start. In that, and the other side, have we seen in India that then people buy a project called
Yeah.
projects and then put it. How funny it is, right? We shouldn't degenerate that thing in front of us. As teachers, we should, even if they call us a bad worker, let them call bad man. But you let us be very strict, let them learn better, let them go to industries better actually. Today, Bangalore and India are standing well because of old generation faculties created amazing engineers. That's the reason today, otherwise you don't know how many jokes will be there in 1990s about Bangalore, like, when you go to outside. But today it's established because hard work of community, not one, lakhs of engineers worked hard. Of course, faculties also created in the meanwhile, downline become a kind of, projects are sold and things. Yeah, I don't think we should do that. We should discourage younger students to do that. And also we should encourage them. I think they are better. Uh, Better than knowledge wise for us, but only focus is required. I think Manoj is having some platforms to come out that it's not like selling the project, it's apparatus. We give them apparatus, let them conduct the experiments. Is it Manoj, correct?
Yes, right.
Thank you.
On demand and not in very heavy cost, and they can do it in volume and micro skill kind of, not 6 months or one year, right? Because I have experienced that the students are 6 years behind actuals on ground. So to give this micro skill, they will have a perspective of getting the job and getting up to a mark what actual reality is. So that way we can feel it and make a
Manoj,
smart.
there is a joke. Karthi and teachers, there is a joke. Sorry for the break. There's a joke, a technical joke actually. So there is a new one company. There's a new hiring. They hired a new person. The person went to the table and sitting. The other two people asked, "Hey, how old he'll be?" Like one person is asking another person, and the second person, "Oh, I seen him looking at Excel sheet."
Yeah, I mean, you are right. When I asked a PhD student from GKVK
Uh,
what you have learned, he told, I now am expert in means how to take loan. A PhD student saying this. So monetary part has given a tangent to some of our
yeah.
coming out. So
We are
everybody
poor
is
country, no? Poor country. For us, food is first the top priority, then only research. Actually.
exactly. So means researchers and these people should be respected in monetary terms also, because they are struggling in the India at present. So we are
No,
giving
you
this
don't.
platform.
Here, my advice is don't depend on Indian market, Indian certificates. You go global.
Yeah,
NVIDIA global, ARM is global. If you guys want anything, I can support. I'm ARM ambassador. That's what I'm trying to tell you all. Like be rational and go with that. You don't need to look at the Indian companies at all. It's waste of your time and our time. Actually. Look at the global companies, which they contributed to that.
exactly.
Do we have equivalent of ARM in India? No. I
No,
don't
no.
think that 30 years it will come also. I seen
Mm.
ARM was such a small company when I was very young in Cambridge, 1998 or I when I visited. They ARM 7 to ARM 8, 9 was no 8, ARM 9 was trying to come. That time we trying to put a switch code there. Where no, Cambridge Ring Road, they were there in the UK.
Mhm.
So, now you see how that company, the 10 billion devices.
You can imagine. Yeah,
10
yeah.
billion devices across the globe, whether Apple or Samsung or
Mm.
MediaTek or Qualcomm, everyone is on that, right?
Yeah, yeah.
So,
And now I'm routing all the startups to have company registration from outside India. That is where they will be getting.
don't go that far. Bangalore still safe, don't worry.
I have done for that quantum and all. You can. Oh my God. Thanks, guys. Sorry for these jokes, but on a lighter note.
Yeah, no problem. Don't worry. It's good actually. It's because people should know what is happening in that, correct? In the academics is tightly coupled with the industry. What is going on?
Exactly.
That's the way it is. Like a faculties, once they're fired, they can be much better actually. But whether they're fired or not, the question is correct.
Okay.
But thanks, Kati. If you want a closing note, you can have it, and then we can do.
Yes, sir. So thank you, sir. Actually, really, it was a wonderful section, sir. We have learned many things. More than that, how the discussion was very useful from you and Jayakumar sir and Smriti. It was more informative, and it was very useful for us for our development in how to have some research and how to have some data. Like sir said, what is applying loan like that? Now we can able to do many things. Many things. It's just wonderful have sir. Hopefully, we have future support from you for our many development activities and also. Thank you, sir.
Exactly.
Thanks.
Thanks.
Please
Thank you.
also
Thank you,
come
sir.
to Bangalore. We are not too far from that. Is 3 hours 33 minutes. Only. There is a bus service called 3 hours 33 minutes from Salem to Bangalore. So
Yes, sir. Yes, sir.
Yeah.
thank you all.
Thank you.
Okay, bye.
Thanks.
Thank you.
Thanks a
Thank
lot.
you. Thank
Bye.
you, sir.
Bye.
Thank you, sir. Sir, there is an announcement for the participant. So tomorrow we having section will be at 9:30, and after that we have feedback session also, and then we having assessment. Okay, tomorrow the attendance will be 100% must be there. Make sure you will be available for a full day section tomorrow. Thank you, participant, and thank you all the jury members. Thank you, sir. Manoj sir. Thank you, sir. Thank you.
Thanks.
Thank you, Smriti ma'am.
And one more thing,
Yes,
I will try to say that try to have a ecosystem of startups. I am pushing
Yes,
it in all the universities in India. Mindset of 5% people take university takes 4% equity. And just I'm blunt on this, which IIT Chennai is doing. Same thing we are going to replicate in different universities. And there is nothing called intelligence. Intelligence is by passion in the person. If the person is passionate, he will become intelligent. So, and try to have 2 to 3% of the means a mass student which is exiting as an entrepreneur, and take a 4% stake in the university, and going forward recruitment will be happening in the same company. Right to
okay, sir.
reject will be there for reject will be there from the company itself. So in this way you will be having a student engagement also, and entrepreneurship, and the levy will come to the university also. Try to have this ecosystem.
Yes, sir. We having some iStart through our college campus itself, sir. Through MSME
Okay.
fund we are doing, sir. And we have contact for this, for your point of view, and also we discuss you, sir. For our development. Yes, sir.
Yeah. Okay. Thanks a lot.
Thank you, sir. Thank you, participant. Thank you.